Hello, my dear friends. ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Myself Kodam Naveen Kumar, ನಿಮ್ಮ ಕೆಮಿಸ್ಟ್ರಿ ಫ್ಯಾಕಲ್ಟಿ. ವೆಲ್ಕಮ್ ಬ್ಯಾಕ್ ಯು ಆಲ್ ಟು ದಿಸ್ ಇನ್ಕ್ರೆಡಿಬಲ್ ಪ್ಲಾಟ್ಫಾರ್ಮ್ ಫಿಸಿಕ್ಸ್ ವಾಲಾ. ಈಗ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಏನ್ ಕಲ್ತಿದೀವಿ? ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಲೆಕ್ಚರ್ ನಂಬರ್ 1 ಕಲ್ತಿದೀವಲ್ಲ. ಆ ಲೆಕ್ಚರ್ ನಂಬರ್ 1 ಅಲ್ಲಿ ಏನ್ ನೋಡಿದೀವಿ? ಆಲ್ಕೇನ್ಸ್, ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಅಲ್ಲಿ ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ? ಒಂದು ಆಲ್ಕೇನ್ಸ್, ಆಲ್ಕೀನ್ಸ್, ಆಲ್ಕೈನ್ಸ್ ಅಂಡ್ ದ ಅರೋಮ್ಯಾಟಿಕ್ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಅಲ್ವಾ? ಮತ್ತೆ ಅದು ಪ್ರಿಪರೇಷನ್ಸ್ ಆಫ್ಟರ್ ಇಟ್ಸ್ ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ಮತ್ತೆ ಇಟ್ಸ್ ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟಿ. ಈಗ ಲೆಕ್ಚರ್ ನಂಬರ್ 1 ಅಲ್ಲಿ ಆಲ್ಕೇನ್ಸ್ ಇಟ್ಸ್ ಪ್ರಿಪರೇಷನ್ ನೋಡಿದೀವಿ, ಮತ್ತೆ ಪ್ರಾಪರ್ಟೀಸ್, ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಮತ್ತೆ ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ನೋಡಿದೀವಲ್ವಾ. ನೆಕ್ಸ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ ದಿಸ್ ಇಂಪಾರ್ಟೆಂಟ್, ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್, ದಟ್ ಈಸ್ preparations of the alkene and the physical properties of the alkene and the chemical properties of the alkene. ಇವತ್ತು ಲೆಕ್ಚರ್ ಅಲ್ಲಿ we can see. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? Now let's start our chapter. Now ಈಗ the topics to be covered, what are the topics we are going to cover in this lecture? ಈಗ ಈ ಲೆಕ್ಚರ್ ಅಲ್ಲಿ the topics we are going to cover, ಅದನ್ನ first is preparation of alkenes, preparations of alkenes. Next we are going to see the physical properties. Next we are going to see the physical properties. Next we are going to see the chemical properties or chemical reactivity of the alkenes, chemical reactivity of the alkenes. Okay, now first ಈಗ ಏನ್ ಮಾಡೋಣ? First we have to prepare the alkenes. ಈಗ how we prepare the alkenes ಅಂತ ನೋಡೋಣ. ನೆಕ್ಸ್ಟ್ ಈಗ ಆ ಆಲ್ಕಿನ್ಸ್ ಪ್ರಿಪೇರ್ ಮಾಡ್ತೀವಲ್ವಾ, ಆ ಆಲ್ಕಿನ್ಸ್ ನ ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಏನಂತ ವಿ ಹ್ಯಾವ್ ಟು ಸ್ಟಡಿ. ಆಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಈಗ ಆಲ್ಕಿನ್ಸ್ ಪ್ರಿಪೇರ್ ಮಾಡ್ತೀವಲ್ವಾ, ಆಲ್ಕಿನ್ಸ್ ಹೌ ಇಟ್ ವಿಲ್ ಬಿ ರಿಯಾಕ್ಟ್, ಎಷ್ಟು ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ, ಎಷ್ಟು ಫಾಸ್ಟ್ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ ವಿತ್ ಪೋಲಾರ್ ಸಾಲ್ವೆಂಟ್, ವಿತ್ ನಾನ್ ಪೋಲಾರ್ ಸಾಲ್ವೆಂಟ್, ನಾವು ವಿತ್ ರಿಯೇಜೆಂಟ್, and why it is reacting with the only this reagent and why it is not reacting with the another reagent, ಎಲ್ಲಾನು we can see in the chemical properties of the alkene. Clear? Now alkenes, ಈಗ alkenes general formula CnH2n. now alkanes general formula ಏನು? alkanes general formula ಏನು? CnH2n plus 2 ಅಲ್ವಾ. now alkenes general formula CnH2n. now general name of the alkenes ಏನಂದ್ರೆ olefins. now functional group double bond. now hybridization, ಈಗ ಇದನ್ನ hybridization sp2 bond angle is 120 degree for the sp2 hybridization bond angle will be the 120 degree. now these are the some general information of the alkenes, now ಇಲ್ಲಿ ನೋಡಿ. now here geometrical isomerism, here now alkenes ಇಲ್ಲಿ ನೋಡಿ. first CH, this is CH, ಇದರ ಡಬಲ್ ಬಾಂಡ್, ಇದರಲ್ಲಿ this is hydrogen ಅಲ್ವಾ. now here now this carbon hybridization is sp2, this is ethene. now this carbon hybridization is sp2, this carbon hybridization is sp2, this carbon hybridization is sp2. hybridization ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡಬಹುದು? hybridization is equal to number of sigma bonds plus number of lone pairs. ಈಗ number of sigma bonds ಎಷ್ಟು? 1 2 3. now this is a pi bond ಅಲ್ವಾ, this is pi, this is sigma. now ಈಗ ಈ ಕಾರ್ಬನ್ ಗೆ ಎಷ್ಟು ಸಿಗ್ಮಾ ಬಾಂಡ್ಸ್ ಇದೆ? 3 ಇದೆಯಲ್ವಾ. now number of sigma 3 0. ಈಗ hybridization number 3 ಅಂದ್ರೆ that is sp2. now ಈಗ hybridization number 1 ಅಂದ್ರೆ sp. ಈಗ hybridization number 3 4 ಅಂದ್ರೆ sp, sorry this is 2 ಅಂದ್ರೆ sp. now 4 ಅಂದ್ರೆ sp3, ಕ್ಲಿಯರ್ ಅಲ್ವಾ. ನಾವು ಈಗ ಈ ಕಾರ್ಬನ್ ಗೆ 1 ಸಿಗ್ಮಾ 2 ಸಿಗ್ಮಾ 3 ಸಿಗ್ಮಾ, ಅದಕ್ಕೋಸ್ಕರನೇ ದಿಸ್ ಇಸ್ ಕಾರ್ಬನ್ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಇಸ್ ಆಲ್ಸೋ sp2. ಈಗ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಅಂತ ಕೇಳಿದ್ರಂದ್ರೆ ದಿಸ್ ಕಾರ್ಬನ್ ಈಸ್ ಓವರ್ಲ್ಯಾಪ್ಡ್ ಬೈ ದ sp2 and the sp2. ಕ್ಲಿಯರ್? now ಈಗ ಕಾರ್ಬನ್, ದಿಸ್ ಇಸ್ ಸಿಗ್ಮಾ ಬಾಂಡ್, ಕಾರ್ಬನ್ ಪೈ ಬಾಂಡ್. ಈಗ ಕಾರ್ಬನ್ ಪೈ ಬಾಂಡ್ ಅಂತ ಕೇಳಿದ್ರಂದ್ರೆ ಪ್ಯೂರ್ p orbital by the overlapping of the pure p orbital. Now overlapping. Now pure p orbitals of the pure p orbitals. Now by the overlapping of the pure p orbitals, it is forming the pi bond. It is forming the pi bond. Next, ಈಗ 4 carbon hydrogen sigma bond. ಈಗ 4 carbon hydrogen sigma bond ಅಂತ ಕೇಳಿದಿರ ಅಂದ್ರೆ this was formed by the overlapping of sp2 and the s. sp2 and the s. ಯಾಕಂದ್ರೆ hydrogen is 1s 1 hydrogen having the electronic configuration is 1s1. Now hydrogen is s orbital. Clear? Now this overlapping sp2 overlapping. Now carbon pi bond is formed by the pure p. This is pure p orbital. Now this pure p orbital andre it is not formed in the overlapping. Now ಈಗ ಈ ಸ್ಟ್ರಕ್ಚರ್ ನಿಮಗೆ ಅರ್ಥ ಮಾಡೋಕೆ you have to be careful and you have to understand the topic. ಫಸ್ಟ್ ಇಯರ್ ಟಾಪಿಕ್ ಅದು ಯಾವುದು ಅಂದ್ರೆ ಕೆಮಿಕಲ್ ಬಾಂಡಿಂಗ್. ಈಗ ಕೆಮಿಕಲ್ ಬಾಂಡಿಂಗ್ ಚಾಪ್ಟರ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಕಾನ್ಸೆಪ್ಟ್ if you have understand, now this will be understand for you. If you have not understand, clear, ಈಗ ಕೆಮಿಸ್ಟ್ರಿ ಅಂದ್ರೇನೆ ಇಂಟರ್ಲಿಂಕಿಂಗ್ ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ನಾವು ಒಂದು ಚಾಪ್ಟರ್ ಒನ್ ಚಾಪ್ಟರ್ ಟು ಒನ್ ಚಾಪ್ಟರ್ ಇಟ್ ವಿಲ್ ಬಿ ಇಂಟರ್ಲಿಂಕ್. ಈಗ ದಿಸ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಕಾನ್ಸೆಪ್ಟ್ ಈಗ ನಿಮ್ಗೆ ಅರ್ಥ ಮಾಡೋಕೆ ದ ಫಸ್ಟ್ ಯು ಹ್ಯಾವ್ ಟು ಬಿ ಪರ್ಫೆಕ್ಟ್ ವಿತ್ ದ ಕೆಮಿಕಲ್ ಬಾಂಡಿಂಗ್ ಚಾಪ್ಟರ್. ಕ್ಲಿಯರ್? ನೌ ಡನ್. ನೆಕ್ಸ್ಟ್ ಜಾಮೆಟ್ರಿಕಲ್ ಐಸೋಮರಿಸಮ್. ಇದರಲ್ಲಿ we are going to see the two types of the geometrical isomerism. One is no, this is cis. ಈಗ similar groups are parallel to each other. If the similar group are parallel to each other, then we call it as a what we call it as a cis. Clear? No. ಈಗ if similar groups are opposite to each other, no, if it is opposite to each other, then we call it as a trans. Okay, then we call it as a cis, that we call it as a trans. Clear? Now here if any compound, if they have given like this CH3 double bond H. ಈಗ this type of the compound ಏನಾದರೂ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ if the identical groups are at same side, ಈಗ identical groups are at the same side are attached to the same carbon. If the identical groups are attached to the same carbon, then no cis and trans. There is no cis and trans. Clear? There is no cis and trans is formed. ಈಗ identical groups if it is attached to the same carbon ಇದೆ ಅಂದ್ರೆ there is no cis and trans. Okay? Now ಈಗ if carbon double bond carbon ಇದರಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಇದರಲ್ಲಿ ಅಯೋಡಿನ್, ಇದರಲ್ಲಿ ಬ್ರೋಮಿನ್, ಇದರಲ್ಲಿ ಫ್ಲೋರಿನ್, ಇದರಲ್ಲಿ ಕ್ಲೋರಿನ್. ಈಗ ಈ ತರ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ here we cannot say the cis and trans are the geometrical isomerism. But ಇದರಲ್ಲಿ ಈಗ ಈ type of compound ಕೊಟ್ಟಿದ್ರಂದ್ರೆ we cannot say whether this is a cis and trans. ಇದರಲ್ಲಿ we can say whether it is E or Z, upon the CIP rules. Based upon the CIP rules, we can based upon CIP rules, we can identify it is E or Z. Okay, whether it is E or Z. Clear? Now according to the CIP rule ಅಲ್ಲಿ most atomic number is given as a high priority. ಇದರಲ್ಲಿ iodine ಮತ್ತೆ chlorine ಅಲ್ಲಿ iodine is a high atomic number ಅಲ್ವಾ, so 1. ಇದರಲ್ಲಿ this is 2. Now ಇದರಲ್ಲಿ bromine ಮತ್ತೆ fluorine ಅಲ್ಲಿ high atomic number should be given the high priority ಅಲ್ವಾ. Now this is 1. Now this is 2. Clear? ಈಗ high priority groups are at the high priority groups are at the parallel side. High priority groups are at the parallel side. Then we say this as a Z conformation. Then we can say it as a Z conformation. Now next, ಈಗ if they have given in this manner, iodine ಇದರಲ್ಲಿ ಕ್ಲೋರಿನ್, ಇದರಲ್ಲಿ ಫ್ಲೋರಿನ್ ಮತ್ತು ಇದರಲ್ಲಿ ಬ್ರೋಮಿನ್. ಈಗ ಈ ತರ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ ನಾವು ದಿಸ್ ಈಸ್ 2, ದಿಸ್ ಈಸ್ 1, ನಾವು ಇದರಲ್ಲಿ 1, ಇದರಲ್ಲಿ 2. ನಾವು ಹೈ ಪ್ರಿಯಾರಿಟಿ ಗ್ರೂಪ್ಸ್ ಆರ್ ಆಪೋಸಿಟ್ ಟು ಈಚ್ ಅದರ್. ಈಗ ಹೈ ಪ್ರಿಯಾರಿಟಿ ಗ್ರೂಪ್ಸ್ ಆರ್ ಆಪೋಸಿಟ್ ಅಂದ್ರೆ ಮೀನ್ಸ್ ವಿ ಕ್ಯಾನ್ ಸೇ ಇಟ್ ಆಸ್ ಅ ಹಿ. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ನಾವು ಸಿಸ್ ಅಂಡ್ ಟ್ರಾನ್ಸ್, now 2 should be parallel to each other. Clear? And if the identical groups are attached to the same carbon, then there is no cis and trans. ಈಗ ಈ ತರ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ now based upon the CIP rules we can identify, we cannot say whether this is a cis and trans, we can identify whether this is a E or Z. Clear? Next. ಈಗ preparations of the alkenes. ಈಗ ಮೊದಲ first we are going to prepare the preparation of the alkenes. ಅದರಲ್ಲಿ preparation of alkenes ಅಲ್ಲಿ the first we are going to see the dehydration of alcohols. Dehydration ಅಂದ್ರೆ ಏನಂದ್ರೆ, dehydration ಅಂದ್ರೆ elimination of H2O. ಈಗ alcohols ಇಂದ we can prepare the alkenes. Now this is the various dehydrating agents. Now this is very very important. This is e reagents, whatever the reagent, first concentrated H2SO4 at high temperature of 170 to 180 degree acts as a brown-state acid and the H plus donor. Clear? Now this reagent idralli they may give anyone. Clear? Now this concentrated H2SO4 will also act as a dehydrating agent. Now next H3PO4 idralli it may act as a dehydrating agent. Now Al2O3 at the high temperature it may act as a Lewis acid. Now heating with the P2O5 or P4O10, this one also will act as a dehydrating agent. Now heating with the potassium sulfate, this will act as a dehydrating agent. Now these are the for the preparations of the alcohol. Now dehydration of the alcohols. Now these are the reagents we are going to use. Either we can use this one, either we can use this one, either we can use this one, either we can use any out of this 5, anyone we can use. Now ಈಗ ಇದರಲ್ಲಿ concentrated H2SO4 ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ this temperature will play very very important role. Now ಈಗ alcohols ಗೆ concentrated H2SO4 ಈಗ ಕೊಟ್ಟಿದ್ದೀರಾ ಅಂದ್ರೆ ಟೆಂಪರೇಚರ್ ನೋಡಬೇಕು. ಟೆಂಪರೇಚರ್ will play very very important role. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ನಾವು ಆರ್ಗಾನಿಕಲ್ಲಿ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಅಲ್ಲಿ ಇಂದ ಕ್ವಶನ್ಸ್ ಕೇಳಿದಿರ ಅಂದ್ರೆ they will ask the questions in the form of IUPAC names, or else what they will do, they will give the reactant and they will give the product and they will ask the reagent. What is the reagent? Or they will ask the intermediate. Clear ಆಯ್ತಲ್ವಾ? ಅದಕ್ಕೋಸ್ಕರನೇ GOC ಮತ್ತೆ hydrocarbons is very very important chapter. Now ಈಗ this type of the reagent ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ಟೆಂಪರೇಚರ್ ನೋಡಬೇಕು. ಕ್ಲಿಯರ್? ನಾವು ಯಾಕಂದ್ರೆ ಬೇರೆ ಟೆಂಪರೇಚರ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ಬೇರೆ ಪ್ರಾಡಕ್ಟ್ಸ್ ಬರುತ್ತೆ. ಕ್ಲಿಯರ್? ದಟ್ ಆಲ್ಸೋ ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಯು ಕ್ಲಿಯರ್ಲಿ. ನಾವು ಈಗ these are the reagents we are going to use for the dehydrating agent. Any of this they can give. ಇದು ನೆನಪಿಟ್ಕೋಬೇಕು. ಕ್ಲಿಯರ್? ನಾವು this reagents ನೆನಪಿಟ್ಕೋಬೇಕು. ಕ್ಲಿಯರ್? ಈಗ this type of ಒಂದು reactant, this is the reagent. Now what is the product? Now concentrated H2SO4. Now ಇದರಲ್ಲಿ ನೋಡಿ first ಈಗ if they have given this type of the reactant, now it will follow now, or else now ಇಲ್ಲಿ ನೋಡಿ, now this will act as a ಅದು brown state acid ಅಲ್ವಾ, ಅಂದ್ರೆ it will give the it will give the H plus, and this is a HSO4 minus is a conjugate base alva, conjugate base. Now what is the product anta nodona. Now let's see the mechanism. Clear? Now here CH3, now H, now this is a H, now this is a H, now idralli CH, now OH, now idralli we are having H plus alva. Now oxygen mele lone pair ideyalva. Now oxygen mele lone pair en madutandre, now this oxygen lone pair, it will given to the electron deficient species, and it will form, now it will form CH3, now H, it is CH2, now CH2, now this will form the oxonium ion. Now this is a oxonium ion. More electronegative group bearing the positive charge is unstable. Now oxonium ion, it will take this bond pair of electron and leave as a H2O. Now H2O is a good leaving group. H2O is a good leaving group. Clear? Now iga H2O is a good leaving group alva. Now what we'll get? CH3, now H, now idralli H, now idralli H, now idralli H, now idralli H. Now this is a positive charge. Clear? Now now this is following the even mechanism. Andre unimolecular elimination reaction. Now unimolecular elimination reaction alli, now this carbocation is a primary carbocation alva. Now stability order of the carbocation yavadu? Stability order of the carbocation, that is 3 degree, next is 2 degree, next is 1 degree alva. 2 degree, 3 degree, and the 1 degree. Can I make this as a stable carbocation? Can I make this as a more stable carbocation? Iga nanu more stable carbocation ಮಾಡಬೇಕು. I can make alva. Now to make the more stable carbocation ಮಾಡೋಕೆ what I have to do? I have to shift 1,2 hydrate shift ಮಾಡಬೇಕು. 1,2 hydrate shift. ಈಗ 1,2 hydrate shift ಅಂದ್ರೆ now hydrogen is going with the bond. ಈಗ hydrogen is going with the negative charge. Clear? Now idralli next we'll get the CH3, now H, now idralli hydrogen, idralli positive charge, now idralli CH3. Clear? Now this is a secondary carbocation. More I can make the stable carbocation. ಈಗ more stable carbocation ಮಾಡೋಕೆ now what I have to do? I have to shift 1,2 another hydrogen shift. ಈಗ ಇನ್ನೊಂದು hydrogen shift ಮಾಡಬೇಕು. ಕ್ಲಿಯರ್? ಬಟ್ ಈಗ ನಿಮಗೆ ಒಂದು ಡೌಟ್ ಬರುತ್ತೆ, ಸರ್ ಇದರಲ್ಲಿ CH3 ಇದೆ ಮತ್ತೆ ಹೈಡ್ರೋಜನ್ ಇದೆ, ಸರ್ ವೈ ಯು ಹ್ಯಾವ್ ಶಿಫ್ಟೆಡ್ ದ ಹೈಡ್ರೋಜನ್ ಓನ್ಲಿ, ವೈ ನಾಟ್ ದ ಮಿಥೈಲ್? ಬಟ್ ಇದರಲ್ಲಿ ಮೈಗ್ರೇಟಿಂಗ್ ಕೆಪಾಸಿಟಿ ಆರ್ ಮೈಗ್ರೇಟಿಂಗ್ ಆಪ್ಟಿಟ್ಯೂಡ್, ಮೈಗ್ರೇಟಿಂಗ್ ಕೆಪಾಸಿಟಿ ಅಲ್ಲಿ hydrogen is having more migrating capacity than the CH3. ಅದಕ್ಕೋಸ್ಕರನೇ hydrogen is migrating. Now then after now we'll get the CH3. now ಇದರಲ್ಲಿ CH3, now here the carbocation, now ಇದರಲ್ಲಿ CH2, now ಇದರಲ್ಲಿ CH3. Clear? Now ಈಗ this is the stable carbocation. Now this is the stable carbocation alva. Now ಈಗ ಈ stable carbocation, ಈಗ this stable carbocation, now it was decided by, ಈಗ this stable carbocation, now the product was being decided by the Sedgwick rule. Product was decided by the Sedgwick rule. Now product has been decided by the Sedgwick rule. Product was been decided by the Sedgwick rule. ಏನಂದ್ರೆ Sedgwick rule ಏನಂದ್ರೆ, now hydrogen will be eliminated from the carbon which contain less number of hydrogen. Now product decided by Sedgwick rule. Product decided by the Sedgwick rule. Sedgwick rule ಏನಂದ್ರೆ hydrogen will be eliminated by carbon which contain less number of hydrogens. Carbon which contain less number of hydrogens. From there the hydrogen will be eliminated. Idರಲ್ಲಿ ನೋಡಿ, this carbon having a more number of hydrogen, this carbon more number of hydrogens are there. Now ಈಗ this carbon is having the less number of hydrogens ಅಲ್ವಾ, from this hydrogen will be eliminated and the product will be get like this, CH3. Now idರಲ್ಲಿ CH3. Clear? Now here H, really H. Clear? Now here this hydrogen will be shifted. Now here this is eliminating. Now here the hydride is not shifting, proton is shifting. Hydrogen will be eliminated from this. Now this will be eliminated as a H plus alva. Now this will be eliminated as a H plus, and here the CH. Now this is a CH3. Now this has been eliminated as a H plus alva. This has been eliminated as a H plus. Now here we are having conjugate base. This is conjugate base. Now this H plus will be attacked with this conjugate base. This H plus will be attacked with the conjugate base, and again it will form the H2SO4. Again the reagent is restored. And this is the product obtained. Now this is the product obtained. Now this is product was being decided by the yaudu, that is decided by the Sedgwick product or Sedgwick rule. This was decided by the Sedgwick rule. Now idರಲ್ಲಿ carbocation migrating aptitude Sedgwick rule. Clear? Now preparation of the alkanes ಅಲ್ಲಿ now three concept has been involved. Clear ಆಯ್ತಲ್ವಾ? Now this is the product, CH3. Now CH3 double. Now hydrogen. Now this is the CH3. Clear? Now this is the product. Now the elimination of the from the alcohols in the we can prepare the alkene. Idರಲ್ಲಿ we are going to see the this will follow the E1 mechanism. This will follow the E1 mechanism. ಈಗ if you are in the first year or PUC 1 ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ elimination reaction ಅಂದ್ರೆ second year ಅಲ್ಲಿ ನಿಮಗೆ ಅರ್ಥ ಆಗುತ್ತೆ. ಈಗ if you are in the second year and if you are the droppers, easily you can understand. Clear? Now carbocation ಇದರಲ್ಲಿ 3 degree 2 degree 1 degree. ಇದರಲ್ಲಿ I can make the more stable carbocation by shifting the hydrate shift ಅಂದ್ರೆ it is going with the negative, it will taking the bond pair of electrons. Clear? Now ಇದರಲ್ಲಿ ನೋಡಿ, here it is giving the bond. Clear? ಅದಕ್ಕೋಸ್ಕರನೇ arrows here ನೋಡಬೇಕು. Clear ಆಯ್ತಲ್ವಾ? Now this is a preparation of the alkene. Now next ಈಗ ಈ ತರ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ same it will form. What it will happen? Now ಇದರಲ್ಲಿ these are the methyls. Now OH ಇದೆ ಅಲ್ವಾ? Now by taking the H plus ಈಗ by taking the oxygen ಮೇಲೆ lone pair, by taking the H plus, now it will form the oxonium ion. Oxonium ion by taking the bond pair of electrons, now it will form the positive charge. Now ಇದರಲ್ಲಿ hydrogens ಇರುತ್ತಲ್ವಾ? Now 1,2 hydrate shift will be happen. Now 1,2 hydrate shift will be happen. Now ಇದರಲ್ಲಿ the positive charge. Now ಇದರಲ್ಲಿ methyl. Now ಇದರಲ್ಲಿ there is no hydrogen ಅಲ್ವಾ? All are CH3. ಈಗ ಈ ತರ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ these all are CH3. Now there is no hydrogen. There is no more we can make the stable carbocation alwa. Now by shifting the methyl, idರಲ್ಲಿ 1,2 1 comma 2 CH3 transfer, methyl transfer will be happened. Clear? Now idralli methyl, now idralli this is a stable carbocation. Now this is the stable carbocation. Now this is a stable carbocation alva. Now the hydrogen, now the product will be decided by the set of product alva. Now product will be decided by the set of product. Product will be decided by the set of product. Idralli 3 hydrogens. Idralli 3 hydrogens. Now idralli 3 hydrogens. CH3 alva. Now idralli 3 hydrogens. Now but here we are having only 1 hydrogen. Now idralli 3 hydrogens. Idralli 3 hydrogens. Clear? Now the hydrogen will be, according to the Sirjoff rule, hydrogen will be eliminated from the carbon which contain less number of hydrogens alva. Now this will be eliminated like this, and the product will get. Now this is a product. Now this is a product will get. Clear? Now this is the product we get. This is the product we get. Clear aitalva? Now next ring. ಈಗ ರಿಂಗ್ ತರ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ you have to be very careful. ಈಗ ರಿಂಗ್ ತರ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ you have to be very very careful. Now what we have to do ಅಂದ್ರೆ, now same lone pair, now it is having the H plus alva. Now H plus, now it will take the H plus and it will form. Now here I am writing the mechanism. Now it will form the OH plus. H plus is the alva. Just taking the H plus. Now oxonium ion. Now it is take the what? It will take the bond pair of electrons and it will form the here the CH2 positive. Here it is very very important. It is very very important. Now ring adjacent. Here you have to be very careful. Ring adjacent carbon, ring adjacent carbon, if it has ring adjacent carbon, if it has positive charge, ring attached, or else like write like this, ring attached, this is ring attached carbon, if it has positive charge, a ring attached carbon, if it has positive charge, it was stabilized by ring expansion. It was stabilized by the ring expansion. Iga ring attached carbon, ring attached carbon mele positive charge idi andre, now that carbocation is stabilized by the ring expansion. Iga ring expansion alli 5 membered ring will be expanded to the 6. Clear? Now 4 membered ring will be expanded to the 5. Clear? Now iga idralli 5 membered ring alva. Now this is 5 membered ring. Now 5 membered ring will be expanded to the 6 membered ring. Now how it will be expanded anta iga namage torsini. Let's give the numbering. Idralli 1, idralli 2, now this is 3, now this is 4, now this is 5, this is 6. Clear? Now this entire bond will be shifted toward the 6 number carbon. Clear? Now when it is shifted toward the 6 number carbon, now this is CH2 plus. Now 6 number carbon, total this bond pair of electron has been shifted to this 6 number carbon alva. So 6 number carbon will get the negative charge. 6 number carbon will get the negative charge. Now idralli 1, 2, 3, 4, 5, 6. Clear? Now here 2 number carbon has lost its bond pair of electron alva, adikoskara this is positive charge. Now illi nodi 6 number carbon matte 1 number carbon will form a bond. 6 number carbon matte 1 number carbon will be form a bond. Now after the formation of the bond, it is 6-membered ring alva. Now this is a 6-membered ring. Now this is a 6-membered ring. Now give the numbering again. Now 1 2 3 4 5 6. Now here which number carbon is having a positive charge? 2-number carbon is having the positive charge alva. So this 2-number carbon is having the positive charge. 2-number carbon is having the positive charge. Now this carbocation is stabilized by the Sedgwick product alva. Now this carbocation is stabilized or product is decided by the Sedgwick product alva. Now this carbocation is stabilized by the Sedgwick product. Sedgwick products andre hydrogen will be eliminated from the less number of carbon which contain less number of hydrogen. Idralli 2 hydrogens. Now idralli 2 hydrogens. So hydrogen can be eliminated from 1-member carbon or 3-member carbon. So I am eliminating from the 3-member carbon. Now the product I will get. Now this is a product. This is the product. Clear? Now this statement is very, very important. This statement is very, very important. Ring attached carbon, if it has a positive charge, ಈಗ ring attached carbon ಗೆ positive charge ಇದೆ ಅಂದ್ರೆ it was stabilized by the ring expansion. It was stabilized by the ring expansion. Clear? Now this is a product. This was stabilized by the ring expansion. Clear? Next. If ಈಗ ಈ ತರ ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ H2SO4 ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಕೊಡುತ್ತಲ್ವಾ. ನಾವು ಇಟ್ ವಿಲ್ ಗಿವ್ oxonium ion. It will form the oxonium ion. ಈಗ oxonium ion ಅಲ್ಲಿ now oxonium ion it will eliminate as a H2O. It will eliminate as a H2O. And if it is clear, no sorry, if it is having a CH2, okay. Now here if ಈಗ this is positive charge alva. No, here there is no ring expansion will be happened. Here there is no ring expansion will be happened. When the ring expansion will be happened, ring attached carbon, ಈಗ ring attached carbon, if it is having a ring attached carbon, if it is having a positive charge, now that carbocation is stabilized by the ring expansion alva. But if positive charge, ಈಗ if positive charge is, ಈಗ if positive charge is present on, ಈಗ positive charge, if the positive charge is present on ring carbon only, now positive charge is stabilized by the hydride shift, hydride or methyl shift, hydride or methyl shift. Now this point is very, very important. Clear? Now hydride or the methyl shift. Clear? Now idralli ನೋಡಿ. Now this is a secondary carbocation alva. Now I can make it as a more stable carbocation. Now this is a CH3. Now ಇದರಲ್ಲಿ ಇನ್ನೊಂದು ಹೈಡ್ರೋಜನ್ ಇರುತ್ತಲ್ವಾ, more stable carbocation I can make. Now by shifting the 1,2 hydride shift, 1,2 hydride shift. Clear? Now by taking this total bond pair of electron, now it will be shifted. Now, clear? Now here we will get the positive charge. Now this positive charge will be stabilized by the, this positive charge is stabilized by the, ಈಗ ಈ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ವಿಲ್ ಬಿ ಸ್ಟೆಬಿಲೈಸ್ಡ್ ಬೈ ದ Sedgwick ಪ್ರಾಡಕ್ಟ್ ಅಲ್ವಾ. ನಾವು Sedgwick ಪ್ರಾಡಕ್ಟ್ ಅಂದ್ರೆ ಕಾರ್ಬನ್ ವಿಚ್ ಕಂಟೈನ್ ಲೆಸ್ ನಂಬರ್ ಆಫ್ ಹೈಡ್ರೋಜನ್, ಅದರಲ್ಲಿಂದ ಹೈಡ್ರೋಜನ್ ವಿಲ್ ಬಿ ಎಲಿಮಿನೇಟೆಡ್ ಅಲ್ವಾ. ನಾವು ಇದರಲ್ಲಿ 3 ಹೈಡ್ರೋಜನ್ಸ್ ಇರುತ್ತೆ. ಕ್ಲಿಯರ್? ನೌ ಈಗ ಹೈಡ್ರೋಜನ್ ಕ್ಯಾನ್ ಬಿ ಎಲಿಮಿನೇಟೆಡ್ ಫ್ರಮ್ ಐದರ್ ದಿಸ್ ಕಾರ್ಬನ್ ಆರ್ ಎಲ್ ದಿಸ್ ಕಾರ್ಬನ್. ಈಗ ಹೈಡ್ರೋಜನ್ಸ್ ವಿಲ್ ನಾಟ್ ಬಿ ಎಲಿಮಿನೇಟೆಡ್ ಫ್ರಮ್ ದಿಸ್ ಕಾರ್ಬನ್, ಯಾಕಂದ್ರೆ ಇದರಲ್ಲಿ 3 ಹೈಡ್ರೋಜನ್ಸ್ ಇದೆಯಲ್ವಾ. ನಾವು ಇಟ್ ವಿಲ್ ಬಿ eliminated, either it can be eliminated from this, either it can be eliminated, and the product will get it as a, now this is a product will get, clear? ಈಗ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ನೋಡಬೇಕು. ಈಗ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ನೋಡಬೇಕು. ಈಗ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ is attached to the ring carbon. ಈಗ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ is present on the ring carbon, it will be stabilized. ಈಗ ಈ carbocation is stabilized by the hydride shift. Clear? No, ಇದರಲ್ಲಿ if the positive charge is present on the ring, ಈಗ positive charge ring adjacent carbon, ring attached carbon, ಈಗ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ ಅಂದ್ರೆ that positive charge is stabilized by the ring expansion. Clear ಆಯ್ತಲ್ವಾ? Now here this is following the even mechanism, non-concerted, it follows the non-concerted mechanism, and it is intermediate, its intermediate is carbocation, its intermediate is a carbocation. Clear ಆಯ್ತಲ್ವಾ? Now this is a very very important. Now ಈಗ this is very very important. Now ಈಗ I said alva, what I said now 1 degree alcohols ಈಗ ಬಿದ್ದ different temperature ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ, ಈಗ ಬೇರೆ ಟೆಂಪರೇಚರ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ only with the 1 degree alcohols, ಈಗ 1 degree alcohols upon concentrated H2SO4 different temperature ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ, now with 413 Kelvin temperature ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ we'll get the ethers. Clear? Now here we'll get the alkenes, ಈಗ 100 degrees ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ we'll get the CH3 CH2 SO3H. okay, sulfonic acid. Now clear ಆಯ್ತಲ್ವಾ? Now this is very very important. Now these temperatures will play very very important role. This temperatures will be very very important role. ಈಗ statement based question they may ask. Clear ಆಯ್ತಲ್ವಾ? Now ಈಗ this is homework questions for you. Now dehydration of alcohols ಅಲ್ಲಿ 3 questions ಕೊಟ್ಟಿದ್ದೀನಲ್ವಾ? ಈಗ this IUPAC name of the products, first question, second question, third question. ಈಗ ಕಾಮೆಂಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಕಾಮೆಂಟ್ ಮಾಡಿ products IUPAC name ಕಾಮೆಂಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಕಾಮೆಂಟ್ ಮಾಡಿ. ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್ ಪ್ರಿಪರೇಷನ್ ಆಫ್ ಆಲ್ಕಿನ್ಸ್ ಅಲ್ಲಿ ಇನ್ನೊಂದು in the another form from the second. Now first dehydration of alcohols in the alkenes we have prepared alva. Now from the alkynes indanu we can prepare the alkenes, now adralli the first is the Birch reduction. Now this is very very important. This Birch reduction it will give the trans alkene. Or else now this Birch reduction it will give the trans alkene. Now how it will give the trans alkene? Here nodi. Now this is trans alkene. Trans alkene how it will give anta you can see mechanism. Now here R C triple bond C R alva. Now here this is lithium and the sodium, these are more electropositive in nature. This will readily lose the 1 electron salva. Now this will readily lose the 1 electron. Clear? Now this is symmetrical alkyne. Either this pi bond may be shifted toward this carbon or this may be shifted toward this carbon, because this is symmetrical alkyne alva. Now here this is lithium, it will readily lose 1 electron. These are more electropositive in nature. Clear? Now R C double bond, now idralli positive charge, now this carbon mele negative charge alva. Now iga this 1 electron, now this electron is alva, now this 1 electron will be taken by this positive charge. Now here R C, now idralli 1 electron of this carbon or double bond. Now here negative charge andre 2 electrons alva, two electrons. Now R. Clear? Now idralli nodi ಈಗ ಈ electron ಮತ್ತೆ ಇದರಲ್ಲಿ negative charge, ಈ electron ಮತ್ತೆ ಈ negative charge electrons will repel each other alva if they are having the same side. Now this if it is repel each other, negative charge ಮತ್ತೆ negative charge, these two will be repel alva, adugoskaraನೆ this will rotate in this manner. This negative charge will be rotate in this manner. Okay? Now here liquid ammonia ಇದೆಯಲ್ವಾ, liquid ammonia ಏನು ಕೊಡುತ್ತೆ ಅಂದ್ರೆ it will give the proton, it will give the H plus. Now this H plus was attacked to here. Now what will get? R C double bond, hydrogen ಇದರಲ್ಲಿ R. Clear? Now here more metals will be there alva. Now another one electron, again it will gain, another one electron, again it will gain. Now see, now it will become negative charge. By taking the another electron, it will have the negative charge alva. Hydrogen, now idralli R. Now liquid ammonia, it will give the H plus. Now this H plus will be attacked here, and the product will get the trans alva. This is trans because identical groups are opposite to each other. In the Birch reduction alli, what we are getting? Trans alkene. Now this is the mechanism. Trans alkene. Birch reduction alli we are getting the trans alkene. Next, ಈಗ ಲಿನ್ಲಾರ್ಡ್ಸ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಕೊಟ್ಟಿದ್ರ ಅಂದ್ರೆ ಒಂದೇ ಒಂದು ನೆನಪಿಟ್ಕೋಬೇಕು. ಲಿನ್ಲಾರ್ಡ್ಸ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಕೊಟ್ಟಿದ್ರ ಅಂದ್ರೆ ನಾವು this will give the what it will give? This will give the cis alkene. Now this will give the cis alkene. ಈಗ ಲಿನ್ಲಾರ್ಡ್ಸ್ ಕ್ಯಾಟಲಿಸ್ಟ್, this will give the cis alkene. Clear? Now when it will give the cis alkene? Now if you maintained quinoline or the poisoned sulfur. Now palladium in the presence of BaSO4, poisoned sulfur or quinoline use ಮಾಡಿದ್ವು ಅಂದ್ರೆ now this will partially reduction ಆಗುತ್ತೆ. ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ this will be one, and it will be stop this poisoned sulfur or quinoline. What it will do andre it will stop the reaction at the alkene stage only. If these two are not present, ಈಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ if these two are not present, ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ directly it will be converted to the alkene. ಈಗ catalytic reduction ನೋಡಿದೀವಲ್ವಾ, catalytic reaction. Now palladium or platinum or the nickel at the high temperature, alkynes directly will be converted to the alkenes alva. Alkynes directly converted to the alkenes. Now ಈಗ if we maintain, this is Rosenman reduction also. Rosenman reduction ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ now acid halides will be converted into aldehydes. Now ಇದರಲ್ಲಿ ಈಗ ಪಾಸಿಟಿವ್ ಪಾಯ್ಸನ್ಡ್ ಸಲ್ಫರ್ ಆರ್ ಕ್ವಿನೋಲಿನ್ ಯೂಸ್ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ಡೈರೆಕ್ಟ್ಲಿ ಇಟ್ ವಿಲ್ ಬಿ ಕನ್ವರ್ಟೆಡ್ ಟು ದ ಆಲ್ಕೇನ್. ಈಗ ಇಫ್ ಯು ಮೇಂಟೈನ್ಡ್ ಆರ್ ಇಫ್ ಯು ಪಾಯ್ಸನ್ಡ್ ದ ಸಲ್ಫರ್ ಆರ್ ಕ್ವಿನೋಲಿನ್ ಮೇಂಟೈನ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ಸ್ಟಾಪ್ ದ ರಿಯಾಕ್ಷನ್ ಎಟ್ ದ ಸಿಸ್. ಓಕೆ, ಅಂದ್ರೆ ಲಿನ್ಲಾರ್ಡ್ಸ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ವಿಲ್ ಗಿವ್ ದ ಸಿಸ್ ಆಲ್ಕೀನ್. ನಾವು ಬರ್ಚ್ ರಿಡಕ್ಷನ್ ವಿಲ್ ಗಿವ್ ದ ಟ್ರಾನ್ಸ್ ಆಲ್ಕೀನ್. ಕ್ಲಿಯರ್? ಈಗ ಕ್ವಶನ್ ನೋಡೋಣ. ನಾವು ಈಗ ಈ ತರ ಒಂದು ಆಲ್ಕೈನ್ ಕೊಟ್ಟಿದ್ರೆ ನಾವು ಹಿಯರ್ H2 ಪ್ಲಸ್ now this is the Lindlards catalyst alva. Lindlards catalyst, it will give the cis alva. Now this is Birch reduction, it will give the trans. Birch reduction, it will give the trans. Clear? Now this is cis, this is trans. Now two are geometrical isomerisms alva. Now two are geometrical isomerism. Now this is 2 butane upon Lindlards catalyst and the Birch reduction. We are getting the geometrical isomerism. ಒಂದು cis ಒಂದು ಮತ್ತೆ trans. Clear? Now ಇದರಲ್ಲಿ Lindlards catalyst will get the cis. Now Birch reduction will get the trans. This is very very important. ಈಗ ಈ ತರ ರಿಯಾಕ್ಟೆಂಟ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ either on the Lindlards catalyst or the Birch reduction there is no reaction. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, here there is hydrogen ಅಲ್ವಾ, this is a carbon. Now ಇದರಲ್ಲಿ hydrogen. Now what the product will get? Now ಇದರಲ್ಲಿ hydrogen ಮತ್ತೆ ಇದರಲ್ಲಿ now Lindlards catalyst ಅಂದ್ರೆ hydrogens. ನಾವು ಇದರಲ್ಲಿನೂ ಸೇಮ್ ಇರುತ್ತಲ್ವಾ, ನಾವು ಇದರಲ್ಲಿ ಹೈಡ್ರೋಜನ್. ಕ್ಲಿಯರ್? ನಾವು ಇದರಲ್ಲಿನೂ ಹೈಡ್ರೋಜನ್, ಆರ್ ಹೈಡ್ರೋಜನ್. ಸಿ, ನಾನು ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲಿ ಹೈ ಸೈಡ್ ಅಲ್ವಾ, if identical groups are attached to the same carbon, if the identical groups are attached to the same carbon, no cis and trans, no cis and trans, no cis and trans. Clear? Now this is very very important molecule. ಇದನ್ನ ನೆನಪಿಟ್ಕೋಬೇಕು. Clear? Now idralli, now here this is homework question for you, now preparations of alkynes from the alkynes in the alkene we are preparing alva, adralli now idralli this is a product, this is a reactant, now that is a product. What is the reagent we are going to use? Adralli Lillard's catalyst birch reduction verena, that you comment box alli comment ಮಾಡಿ. Now I will see. Clear? From alkyl halides indanu we can prepare the alkenes. From the alkyl halides indanu we can prepare the alkenes. Now that is a dehydrohalogenation. Okay, dehydrohalogenation alli this is very very important. Now here nimge concept, you will know the concept, but by giving the different reagents, by giving the different reagents you may not predict the answer. Adigoskara I have given the different reagents. Now various bases can be used. Now from the alkali halides in the dehydrohalogenation, by making the dehydrohalogenation we are getting the alkenes. Now what are the reagents we are going to use? Adralli first we are going to use alkalic KOH or sodium hydroxide or the cesium hydroxide. Now this is the small base. Now this is a small bases. ಈಗ ಸ್ಮಾಲ್ ಬೇಸಸ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ಈಗ ನಾವು alkali halides with the small bases, it will follow the set of products. Clear? Now alkali metal amides with the liquid ammonia, adralli sodium amide, potassium amide, cesium amide. Now ಈಗ these all are the small bases. ಈ ಎರಡು these are the small bases. Now this is a bulky base. This is a bulky base. Now this is a bulky base. ಈಗ bulky base ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ it will follow the half-main product. Now ಇದರಲ್ಲಿ ಎರಡೂನು ಆಲ್ಕೇನೆ ಕೊಡುತ್ತೆ, but ಇದರಲ್ಲಿ half-main product if the bulky base, ಈಗ bulky base ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ half-main product we will get. ಈಗ small base ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ sets of product ಬರುತ್ತಲ್ವಾ, sets of product. Clear? Now this reagents will play very very important role. ಈಗ ಈ ತರ ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ in the dehydrohalogenation ಅಲ್ಲಿ ಈಗ ಈ reagents, this reagents you have to remember. Clear? ಈಗ ಈ ತರ reagents ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ now here this is tertiary butoxide. ಈಗ tertiary butoxide is a bulky base. Now bulky base it will give the half-main product. Now small base ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ half-main product. Now ಇದರಲ್ಲಿ now we'll see different questions. Now this is ಯಾವುದು? This is small base ಅಲ್ವಾ? This is small base. Now small base will give the set of product alva, will give the set of product. Now the hydrogen will be eliminated from the beta carbon. ಈಗ small base ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ this is alkali halides alva. Now this is alkali halide. Now this is CH3 alva. Now CH3 first ಇದರಲ್ಲಿ you have to know living group capacity. Good living groups. Now which are the good living groups? Strong acid conjugate bases are the good living group. Andre iodine, next Br, next chlorine. Now strong acids conjugate bases are the good living group alva. Good living group andre idralli Cl is a good living group. Now if small base ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ hydrogen will be eliminated from the beta carbon. small base ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ hydrogen will be eliminated from beta carbon. ಈಗ beta carbon ಇಂದನೇ hydrogen will be eliminated. Now beta carbon ಏನಂದ್ರೆ this is ನೋಡಿ functional group attached carbon is a alpha carbon. ಈಗ this is functional group alva. Functional group or any functional group attached carbon is alpha carbon. Now adjacent carbon is the ಬೀಟಾ ಕಾರ್ಬನ್. ಇದರಲ್ಲಿ ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಬೀಟಾ ಕಾರ್ಬನ್. ಈಗ ನಿಮ್ಗೆ ಒಂದು ಡೌಟ್ ಬರುತ್ತೆ, ಸರ್ ವೈ ನಾಟ್ ಯು ಎಲಿಮಿನೇಟ್ ದ ಹೈಡ್ರೋಜನ್ ಫ್ರಮ್ ದಿಸ್ ಬೀಟಾ ಕಾರ್ಬನ್, ವೈ ಯು ಆರ್ ಎಲಿಮಿನೇಟಿಂಗ್ ದ ಹೈಡ್ರೋಜನ್ ಫ್ರಮ್ ದ ಟರ್ಮಿನಲ್. ಯಾಕಂದ್ರೆ ಆಲ್ಕಹಾಲಿಕ್ KOH ಈಗ ಸ್ಮಾಲ್ ಬೇಸ್ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ ಇಟ್ ವಿಲ್ ಫಾಲೋ ಸೆಟ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಅಲ್ವಾ. ನಾವು ಸೆಟ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಈಗ ಹೈಡ್ರೋಜನ್ if this hydrogen is eliminated, if this hydrogen is eliminated from this beta carbon, if this hydrogen is eliminated from this beta carbon, now this will be eliminated like this. ಈ hydrogen this carbon ಇಂದ ಈ beta carbon ಇಂದ hydrogen eliminate ಮಾಡಿದಂದ್ರೆ what it will happen, because we will get the more number of alpha hydrogens, more substituted alkene will get, or more number of alpha hydrogens will be get. ಈಗ small base ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ hydrogen, ನಾವು ಇದರಲ್ಲಿ ಬೇಸ್ ಅಲ್ವಾ, ಬೇಸ್, this is OH minus. ನಾವು ಈ OH minus directly it will take the acidic hydrogen, now beta hydrogen, this will take the beta hydrogen and this bond will be shifted here, and the chlorine is a good living group and it will be eliminated, and the product will get CH3, now CH double bond CH3. Now this is the product we'll get, and iga this is the more product alla. Now we'll get the more number of alpha hydrogens, idರಲ್ಲಿ ನೋಡಿ we are getting the, it is following the set of product and we are getting the more number of alpha hydrogens. See, now iga it is following the more number of alpha hydrogen. Now this is the functional group alva, functional group adjacent carbon is the alpha carbon. Now this is the alpha carbon, now here we are having the more number of alpha hydrogens, idರಲ್ಲಿ ನೋಡಿ more number of alpha hydrogen, alpha carbon attached hydrogens are alpha hydrogens. Clear? Now if you have eliminated hydrogen from the hydrogen from this carbon, ಈ beta carbon ಇಂದ ನೀವು hydrogen eliminate ಮಾಡಿದೀವಿ ಅಂದ್ರೆ you will get the less number of R. Now ಈ beta carbon ಇಂದ hydrogen eliminate ಮಾಡಿದೀವಿ ಅಂದ್ರೆ now what is the product will get? C double bond, now here, now H, now CH2, CH3. Clear? Now ಇಲ್ಲಿ ನೋಡಿ, now this is the functional group alva, now this functional group adjacent carbon is the alpha carbon. Now ಇದರಲ್ಲಿ ಎಷ್ಟು alpha hydrogens? Only 2 alpha hydrogens, ಇದರಲ್ಲಿ ಎಷ್ಟು alpha hydrogen? Total 6 alpha hydrogens. ಅದಕ್ಕೋಸ್ಕರನೇ ಈಗ ಸ್ಮಾಲ್ ಬೇಸ್ ಕೊಟ್ಟಿದ್ರೆ now hydrogen will be eliminated from the beta carbon and we are getting the set of product, set of products ಅಂದ್ರೆ ಏನು, ಇದರಲ್ಲಿ ZSU products are set of products ಅಂದ್ರೆ ಏನು. Now when the hydrogen is eliminated from the terminal carbon, internal carbon, this is a terminal carbon, this is the internal carbon. ಈಗ hydrogen internal carbon ಇಂದ eliminate ಮಾಡಿದೆ ಅಂದ್ರೆ now the product we are getting the set of products are more substituted alkene, or we are getting the more substituted alkene is more major, ಯಾಕಂದ್ರೆ we are getting the more number of alpha hydrogens, the more number of alpha hydrogens ಅಂದ್ರೆ more hyperconjugations will be decided by the alpha hydrogens alva. Now ಈಗ this is minor, ಅದಕ್ಕೋಸ್ಕರನೇ this is a major, this is a minor. Clear ಆಯ್ತಲ್ವಾ? Clear? Now ಈಗ small base ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ we are getting the set of product and we are getting major product, more substituted alkene. ಈಗ bulky base ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ, if the bulky base ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ now we will get the half main product. bulky base ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ half main product ಅಂದ್ರೆ ಏನಂದ್ರೆ, hydrogen will be eliminated by terminal beta carbon. terminal beta carbon. ಈಗ hydrogen will be eliminated from the terminal beta carbon. ಈಗ hydrogen ಎಲ್ಲಿಂದ ಎಲಿಮಿನೇಟ್ ಆಗುತ್ತೆ? ಟರ್ಮಿನಲ್ ಬೀಟಾ ಕಾರ್ಬನ್ ಇಂದ ಎಲಿಮಿನೇಟ್ ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ ಈಗ ಈ ಬಲ್ಕಿ ಬೇಸ್ ಇಂಟರ್ನಲ್ ಕಾರ್ಬನ್ hydrogen to take the internal carbon hydrogen, due to this bulkiness it will not take the internal carbon hydrogen. That's the reason it will take the terminal carbon hydrogen. That's the reason it will not take the hydrogen due to the bulkiness, due to bulkiness it will not take internal hydrogen. ಈಗ ಡ್ಯೂ ಟು ದ ಬಲ್ಕಿನೆಸ್ ಇಟ್ ವಿಲ್ ನಾಟ್ ಏಬಲ್ ಟು ಟೇಕ್ ದ ಇಂಟರ್ನಲ್ ಹೈಡ್ರೋಜನ್. ಅದಕ್ಕೋಸ್ಕರನೇ ಇಟ್ ವಿಲ್ ಟೇಕ್ ದಿಸ್. ನಾವು ಇದರಲ್ಲಿ ದಿಸ್ ಇಸ್ ಅ ಬೀಟಾ ಕಾರ್ಬನ್ ಅಲ್ವಾ, ನಾವು ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ beta carbon. Now ಇದರಲ್ಲಿ this hydrogen will be shifted. Now the chlorine will be eliminated and we'll get the half mined product. Now this is a half mined product. Clear? Now half mined product is major. Now this is a major. Clear? ಇದು major. Clear ಆಯ್ತಲ್ವಾ? ನಾವು ಈಗ ಬಲ್ಕಿ ಬೇಸ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ಹಾಫ್ ಮೈನ್ ಪ್ರಾಡಕ್ಟ್ ಈಸ್ ಮೇಜರ್. ಈಗ ಸ್ಮಾಲ್ ಬೇಸ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ಯಾವುದು ಮೇಜರ್? ಸೆಟ್ ಆಫ್ ಈಸ್ ಮೇಜರ್. ನೆಕ್ಸ್ಟ್, now this is very important. ಈಗ this is very important. Now fluorine is bad living group. The fluorine is bad living group. ಈಗ ಫ್ಲೋರಿನ್ ಈಸ್ ಅ ಬ್ಯಾಡ್ ಲಿವಿಂಗ್ ಗ್ರೂಪ್ ಅಲ್ವಾ. ನಾವು ಯಾವ್ದು ಬೇಸು ನೀವು ಕೊಡಿ, ಇಟ್ ವಿಲ್ ನಾಟ್ ಫಾಲೋ now the hydrogen, the first it will follow even CB mechanism. It will follow the even CB mechanism. Clear? ಈಗ alcoholic potassium hydroxide ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ now hydrogen should be eliminated and the fluorine will be eliminated. But ಈಗ fluorine is not good living group. ಈಗ this is a beta hydrogen. Now this is a beta hydrogen. Now the hydrogen ಈಗ ಒಂದು hydrogen ಈ ತರ ಇರುತ್ತಲ್ವಾ, you may get it out. ಈಗ hydrogen ಈ ತರ ಇರುತ್ತಲ್ವಾ, now this hydrogen will be shifted here. Now fluorine will be eliminated, you may think, but ಈಗ fluorine is a bad living group alwa. ಯಾಕಂದ್ರೆ this is a weak acid conjugate base. Weak acid conjugate bases are the bad living group. Now this will not be eliminated. Fluorine will not be eliminated. Now ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ we have to make it as a conjugate base. ಈಗ ಈ reactant ನೆ we have to make it as a conjugate base. First we have to make the conjugate base. Conjugate base ಅಂದ್ರೆ ಏನು? ಈಗ this is a one reactant alwa, by the elimination of one hydrogen. ಈಗ this is HCl. Now HCl conjugate base ಯಾವುದು? By the loss of H plus. Now Cl minus is a conjugate base. Now Cl minus is also conjugate base. Now ಇದರಲ್ಲಿಂದನು ಫಸ್ಟ್ ನಾನು ಏನು ಮಾಡಬೇಕಂದ್ರೆ ಕಾಂಜುಗೇಟ್ ಬೇಸ್ ಮಾಡಬೇಕು. ಈಗ ಕಾಂಜುಗೇಟ್ ಬೇಸ್ ಮಾಡೋಕೆ ನಾವು ಹೈಡ್ರೋಜನ್, ಈಗ ಯು ಮೇ ಗೆಟ್ ಇಟ್ ಔಟ್. ಈಗ ಹೈಡ್ರೋಜನ್ ಕಾಂಜುಗೇಟ್ ಬೇಸ್ ಮಾಡಬೇಕಂದ್ರೆ ಹಿಯರ್ ನಾವು ಇದರಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಐ ಶುಡ್ ಎಲಿಮಿನೇಟ್ ಫ್ರಮ್ ದಿಸ್ ಇಂಟರ್ನಲ್ ಬೀಟಾ ಕಾರ್ಬನ್ ಆರ್ ಟರ್ಮಿನಲ್ ಬೀಟಾ ಕಾರ್ಬನ್. ನಾವು ಇಲ್ಲಿ ನೋಡಿ, ನಾವು ಬೇಸ್ ಅಲ್ವಾ, ಬೇಸ್ ವಿಲ್ ರೆಡಿಲಿ ಟೇಕ್ ದ ಪ್ರೋಟಾನ್. ನಾನು ಫಸ್ಟ್ ನಾನೇನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದ್ರೆ ಇಫ್ ಐ ಎಲಿಮಿನೇಟ್ ದ ಹೈಡ್ರೋಜನ್ ಫ್ರಮ್ ದಿಸ್ 1 2 3 4. ಈಗ ಥರ್ಡ್ ಬೀಟಾ ಕಾರ್ಬನ್ ಅಲ್ಲಿ ಈಗ ಒಂದು ಹೈಡ್ರೋಜನ್ ನಾನು ರಿಮೂವ್ ಮಾಡಿದ್ದೀನಿ, ಆರ್ ಬೇಸ್ ಇಟ್ ಹ್ಯಾಸ್ ಟೇಕನ್ ದಿಸ್ ಥರ್ಡ್ ಕಾರ್ಬನ್ ಹೈಡ್ರೋಜನ್ ಅಂದ್ರೆ ನಾವು ವಿಲ್ ಗೆಟ್ ದಿಸ್ ಒನ್. Now this will get this conjugate base will get. This is hydrogen from ಈಗ ಥರ್ಡ್ ಕಾರ್ಬನ್. This ಥರ್ಡ್ ಕಾರ್ಬನ್ ಅಲ್ಲಿ ಥರ್ಡ್ ಕಾರ್ಬನ್ ಹೈಡ್ರೋಜನ್. ಥರ್ಡ್ ಕಾರ್ಬನ್ ಹೈಡ್ರೋಜನ್. ಈಗ ಥರ್ಡ್ ಕಾರ್ಬನ್ ಹೈಡ್ರೋಜನ್ ಅಲ್ಲಿಂದ ಈಗ ನಾನು ಹೈಡ್ರೋಜನ್ ರಿಮೂವ್ ಮಾಡಿದ್ದೇನೆ ಅಂದ್ರೆ ನಾವು ದಿಸ್ ಕಾಂಜುಗೇಟ್ ಬೇಸ್. ಕ್ಲಿಯರ್. ನಾವು ಈಗ ಫಸ್ಟ್ ಕಾರ್ಬನ್ ಅಲ್ಲಿ ಆರ್ ಟರ್ಮಿನಲ್ ಕಾರ್ಬನ್, ಇಂಟರ್ನಲ್ ಕಾರ್ಬನ್, ಟರ್ಮಿನಲ್ ಕಾರ್ಬನ್. ಈಗ ಟರ್ಮಿನಲ್ ಬೀಟಾ ಕಾರ್ಬನ್ ಅಲ್ಲಿಂದ నేను ಒಂದು ಹೈಡ್ರೋಜನ್ ರಿಮೂವ್ ಮಾಡಿದ್ದೀನಿ ಅಂದ್ರೆ ಆರ್ ಬೇಸ್ ಇಫ್ ಇಟ್ ಹ್ಯಾಸ್ ಟೇಕನ್ ದ ಹೈಡ್ರೋಜನ್, ನಾವು ದಿಸ್ ಐ ವಿಲ್ ಗೆಟ್. ಈಗ ಈ ಎರಡಲ್ಲಿ ವಿಚ್ ಈಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್ ಕಾಂಜುಗೇಟ್ ಬೇಸ್, ನಾವು ಇದರಲ್ಲಿ ಫಸ್ಟ್ ಒನ್ ಆರ್ ಸೆಕೆಂಡ್ ಒನ್. ನಾವು ಕಾರ್ಬಾನಿಯಾನ್ ಸ್ಟೆಬಿಲಿಟಿ ಆರ್ಡರ್ ನೋಡ್ಬೇಕು. ಇದರಲ್ಲಿ ಕಾರ್ಬಾನಿಯಾನ್ ಸ್ಟೆಬಿಲಿಟಿ ಆರ್ಡರ್ ಯಾವುದು? 1 ಡಿಗ್ರಿ, ನೆಕ್ಸ್ಟ್ 2 ಡಿಗ್ರಿ ಅಂಡ್ 3 ಡಿಗ್ರಿ ಅಲ್ವಾ. ನಾವು ಈಗ ದಿಸ್ ಆಲ್ಕಹಾಲಿಕ್ KOH, ಈಗ ಆಲ್ಕಹಾಲಿಕ್ KOH ಈಗ ಇಂಟರ್ನಲ್ ಕಾರ್ಬನ್ ಇಂದ ಹೈಡ್ರೋಜನ್ ಇಫ್ ಇಟ್ ಹ್ಯಾಸ್ ಟೇಕೆನ್, ನಾವು ವಿ ಆರ್ ಗೆಟಿಂಗ್ ದ 2 ಡಿಗ್ರಿ ಕಾರ್ಬಾನಿಯಾನ್. ನಾವು ಈಗ ಇಫ್ ಇಟ್ ಈಸ್ ಟೇಕೆನ್ ಫ್ರಮ್ ದ ಟರ್ಮಿನಲ್ ಬೀಟಾ ಹೈಡ್ರೋಜನ್, ವಿ ಆರ್ ಗೆಟಿಂಗ್ ದ ಪ್ರೈಮರಿ ಕಾರ್ಬಾನಿಯಾನ್. ನಾವು ಇದರಲ್ಲಿ ವಿಚ್ ಈಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್ ಕಾರ್ಬಾನಿಯಾನ್? ಪ್ರೈಮರಿ ಕಾರ್ಬಾನಿಯಾನ್ ಈಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್ ಅಲ್ವಾ. ನಾವು ದಿಸ್ ಈಸ್ ಅ ಮೈನರ್. ಸೊ ಹೈಡ್ರೋಜನ್ ವಿಲ್ ನಾಟ್ ಬಿ ಟೇಕೆನ್ ಬೈ ದ internal carbon. Hydrogen will not be taken by the internal carbon. Now it will be taken by the terminal carbon. Now ಇದರಲ್ಲಿ this negative charge will be delocalized and the fluorine will be eliminated and the product will get the half main product. Clear. ಈಗ ಫ್ಲೋರಿನ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ಒಂದೇ ಒಂದು ನೆನಪಿಟ್ಕೋಬೇಕು, ಯಾವುದು ಬೇಸನು ಕೊಡಿ. ಈಗ ಫ್ಲೋರಿನ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ನಾವು ವಿಲ್ ಗೆಟ್ ದ half main product only. Half main product only. Clear. Now ಯಾವುದು ಬೇಸನು ಕೊಡಿ. Clear. Now this will give the half main product. Clear. ಈಗ ಫ್ಲೋರಿನ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ half main product. ಯಾಕಂದ್ರೆ this is not the good living group. Fluorine is not the good living group. Clear. Next. ಈಗ ಕ್ವೆಶ್ಚನ್ಸ್ ಕೊಟ್ಟಿದ್ರಲ್ವಾ. Now this is a small base ಅಂದ್ರೆ it will follow the set of product alva. Now the hydrogen will be eliminated. From the internal hydrogen. Now hydrogen will be eliminated from the internal carbon. Now this will be shifted. This will be eliminated for this one. Now we'll get the, now this is the product we'll get. Now this is the product we'll get for the small base. ಈಗ ಬಲ್ಕಿ ಬೇಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ ಇದರಲ್ಲಿ what will get? ಈಗ ಬಲ್ಕಿ ಬೇಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ what will get? Now the hydrogen will be eliminated from the terminal alva. Now the hydrogens will be eliminated from this carbon. Now this will be eliminated like this and this will be eliminated. Now this is a half main product. Now this is a set of product. Clear. Now this is a set of product. This is a half main product. ಈಗ whatever it may be the base. Now ಈಗ ಫ್ಲೋರಿನ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ we'll get the half main product only. Clear. Next, preparation of the alkene. Alkene we can prepare with the vicinal dihalide ಇಂದನು we can prepare the alkene. ಈಗ vicinal dihalide ಅಲ್ಲಿ vicinal ಅಂದ್ರೆ halogens attached to the adjacent carbon. Now this is a vicinal. Vicinal ಅಂದ್ರೆ now halogens are attached to the adjacent carbon. Now ಈಗ geminal ಅಂದ್ರೆ now halogens are attached to the same carbon. The halogens are attached to the same carbon. ಈಗ halogens are attached to the same carbon ಅಂದ್ರೆ this is geminal. ಈಗ vicinal dihalide ಇಂದನು we can prepare the alkene. In the presence of zinc alcoholic, by heating we can prepare the alkene. Clear. No. ಈಗ properties of the alkene. Now ಈಗ what we have seen, ಈಗ ಏನು ನೋಡಿದೀವಿ? We have seen preparations of the alkene alva. Preparation of the alkene ನೋಡಿದ್ವಿ. ನಾವು ಈಗ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ದ ಆಲ್ಕಿನ್ಸ್ ಅಂತ ನೋಡೋಣ. ಈಗ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ದ ಆಲ್ಕಿನ್ಸ್ ಅಲ್ಲಿ ಫಸ್ಟ್ C1 carbon to the C4 carbons are gaseous. C1 carbon in the C4 carbons are gaseous. C5 carbon in the C17 are liquid. Above C18 are the solids. Next, the boiling point of all the hydrocarbons increases with the every CH2 group is added. ಅಂದ್ರೆ ಈಗ ಆಲ್ಗಿನ್ ಅಲ್ಲಿ ಚೇನ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ ಅಂದ್ರೆ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ ಈಗ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತಲ್ವಾ, ಈಗ ಚೇನ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ ಅಂದ್ರೆ ಸರ್ಫೇಸ್ ಏರಿಯಾನು ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಈಗ ಇಷ್ಟು ದೊಡ್ಡದು ಸಬ್ಸ್ಟಾನ್ಸ್ ಹೀಟ್ ಮಾಡೋಕೆ ಮತ್ತೆ ಚಿಕ್ಕದು ಸಬ್ಸ್ಟಾನ್ಸ್ ಹೀಟ್ ಮಾಡೋಕೆ ದೊಡ್ಡದು ಸಬ್ಸ್ಟಾನ್ಸ್ಗೆ ಬಿಸಿ ಮಾಡೋಕೆ ಮೋರ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ರಿಕ್ವೈರ್ಡ್ ಅಲ್ವಾ ಫಾರ್ ಕಂಪೇರಿಂಗ್ ಟು ದ ಸ್ಮಾಲ್ ಒನ್. ಇದರಲ್ಲಿನೂ ಸೇಮ್. ಈಗ CH2 ಗ್ರೂಪ್ ಆಡ್ ಮಾಡಿದ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಸರ್ಫೇಸ್ ಏರಿಯಾ ದೊಡ್ಡದಾಗುತ್ತೆ. ವೆನ್ ದ ಸರ್ಫೇಸ್ ಏರಿಯಾ has become high, boiling point also will become high. Now like the straight chain alkenes have the higher boiling point than the isomeric branched chain alkene. ಈಗ branched chain ಅಂದ್ರೆ ಇದರಲ್ಲಿ ನೋಡಿ, now this is a pentane. Now this is a pentane. Clear? Now this we can write. Now we can write it in this manner also alva. Oh, here how many carbons? 1 2 3 4 5 6 7 8 9 10 11 12. Clear? Now this is for the alkane I am saying. For the alkane it will be different. Now branching increase andre surface area will be decrease. When the surface area decrease, branching also, surface area decrease. Now boiling point is also decrease. Clear? Now boiling point for the cis is more than the trans. The boiling point for the cis is more than the trans. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, cis ಅಂದ್ರೆ ಏನು, this is a cis ಅಲ್ವಾ, this is a cis. The identical groups are parallel to each other. Now that is cis. Okay, trans opposite idi ಅಂದ್ರೆ trans ಅಲ್ವಾ. Now ಇಲ್ಲಿ ನೋಡಿ, here this is a polar. This is a polar. Trans is a non-polar. Now trans is a non-polar ಯಾಕಂದ್ರೆ ಇದರಲ್ಲಿ ನೋಡಿ, now this carbon hybridization is sp2. ಇದರಲ್ಲಿ this carbon hybridization is sp2. ಇದರಲ್ಲಿ this carbon hybridization is sp3. ನಾವು ಈಗ ಪರ್ಸೆಂಟೇಜ್ S ಕ್ಯಾರೆಕ್ಟರ್ ಇನ್ಕ್ರೀಸ್ ಅಂದ್ರೆ electronegativity increases. Clear? Now sp having more percentage S character, next sp2, next sp3 ಅಲ್ವಾ. ನಾವು ಇದರಲ್ಲಿ sp3 ಮತ್ತೆ sp2 ಅಲ್ಲಿ which is more electronegative? Now sp2 is more electronegative, dipole moment will be shifted toward this carbon. Now ಇದರಲ್ಲಿ the dipole moment will be shifted toward this carbon ಯಾಕಂದ್ರೆ this is sp3. Clear? Now ಇದರಲ್ಲಿ dipole moment vector will be cancel out each other and the dipole moment nu is equal to 0. ಅದಕ್ಕೋಸ್ಕರನೇ trans is non-polar. ಇದರಲ್ಲಿ ನೋಡಿ same, this is also sp2. Now ಇದರಲ್ಲಿ this is also sp2. Clear? Now this is now here the dipole moment vector is not cancelling out each other. ಅದಕ್ಕೋಸ್ಕರನೇ this is a polar. ಈಗ polar molecule boiling point is more than the non-polar. Polar molecules boiling point is more than the next. Melting point of the trans isomer is more than the cis because trans is closely packed in the crystal lattice. ಇದರಲ್ಲಿ trans ಅಲ್ವಾ. Now trans is closely packed like this. Now due to the closely packing of the trans, it is having the more melting point than the cis. Clear? Chemical property ಇದರಲ್ಲಿ very important. ಈಗ physical properties of the alkene ನೋಡಿದೀವಲ್ವಾ, chemical properties of the alkene ಅಲ್ಲಿ chemical properties of the most important reactions of the alkenes are the addition reaction. Alkenes will show the addition reaction. ನಾವು ಯಾಕಂದ್ರೆ alkene ಅಲ್ಲಿ ನಾವು pi bond ಇರುತ್ತಲ್ವಾ. now this is ಒಂದು sigma bond, this is ಒಂದು pi bond. now the pi bond is weakly held. now this is pi bond is formed by the pure p orbitals alva, by the sideways overlapping of the pure p orbital. ಈಗ how this pi bond is forming andre, for that you have to see the what chapter? ಕೆಮಿಕಲ್ ಬಾಂಡಿಂಗ್. ಈಗ ಕೆಮಿಕಲ್ ಬಾಂಡಿಂಗ್ ಚಾಪ್ಟರ್ ನೋಡಿದ್ವಿ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗುತ್ತೆ ಹೌ ದಿಸ್ ಪೈ ಬಾಂಡ್ ಇಸ್ ಫಾರ್ಮ್ಡ್, ವೈ ದಿಸ್ ಪೈ ಬಾಂಡ್ ಇಸ್ ವೀಕ್. ಕ್ಲಿಯರ್? ನಾವು ದಿಸ್ ಪೈ ಬಾಂಡ್ ಇಸ್ ವೀಕ್ಲಿ ಹೆಲ್ಡ್ ಅಲ್ವಾ. ನಾವು ದಿಸ್ ಪೈ ಬಾಂಡ್ ಇಸ್ ವೀಕ್ಲಿ ಹೆಲ್ಡ್. ನಾವು ಈಗ ಪೈ ಬಾಂಡ್, ವೆನ್ ದಿಸ್ ಪೈ ಬಾಂಡ್ ಇಸ್ ವೀಕ್ಲಿ ಹೆಲ್ಡ್ ಅಂದ್ರೆ ನಾವು readily it will be break. This pi bonds will be readily break. ಈಗ readily break ಅಂದ್ರೆ now the fusion of the bond may be heterolytic or homolytic. ಈಗ heterolytic ಅಂದ್ರೆ unsymmetrical breakage, homolytic ಅಂದ್ರೆ symmetrical breakage. ಇದರಲ್ಲಿ ನೋಡಿ this is heterolytical breakage. Now this is heterolytical breakage. Now ಇದರಲ್ಲಿ one positive charge, one is negative charge. Now homolytical breakage ಅಂದ್ರೆ now ಇದರಲ್ಲಿ this is pi bond ಅಲ್ವಾ. Now this is homolytical, it is break. Now this one electron has been taken by this carbon, one electron has been taken by this carbon. Now here the radicals will get. Clear? Now this is a homolytical, now this is a heterolytical. But homolytical ಮತ್ತೆ heterolytical breakages will be happen depending upon the solvents. ಇದರಲ್ಲಿ solvents ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ನಾವು ಈಗ polar solvent ಕೊಟ್ಟಿದ್ರಂದ್ರೆ here the heterolytic will be happen. Now non-polar solvent ಕೊಟ್ಟಿದ್ರಂದ್ರೆ free radical will be happen. Polar H2O ಈಗ dipole movement ಇದೆ ಅಂದ್ರೆ that is polar. Now CCl4 ಇದರಲ್ಲಿ this is non-polar. Now H2O is a polar. CCl4 carbon tetrachloride that is a non-polar. ಯಾಕಂದ್ರೆ ಇದರಲ್ಲಿ dipole movement is 0. ಇದರಲ್ಲಿ dipole movement is not 0 because this is having the high dielectric constant. Clear? Now polar solvent, depending upon the polar solvent, now cleavages will be happened for the alkenes. Clear? Now first addition of the dihydrogen. ಈಗ dihydrogen addition to the alkenes ಅಲ್ಲಿ in the presence of nickel high temperature. ಈಗ palladium ಮತ್ತೆ platinum ಕೊಟ್ಟಿದ್ರಂದ್ರೆ now alkenes ಅಲ್ಲಿ ನೋಡಿದಿವಲ್ವಾ, what it all happened. Now here catalyst ಮೇಲೆ this hydrogen will be absorbed, and this will be attacked to this pi bond and will get the alkene. ಈಗ reactivity order also, ಈಗ this addition of the dihydrogen reactivity order also we have seen. ಒಂದೇ ಒಂದು ನೆನಪಿಟ್ಕೋಬೇಕು, stability is inversely proportional to the reactivity. Clear? ಈಗ stability is inversely proportional to the reactivity. ಈಗ what we'll get the alkene. Clear? We'll get the alkene. First chemical property ಅಲ್ಲಿ addition of the dihydrogen. Now this is the chemical reaction of the alkene. Next, addition of the halogen. ಈಗ addition of the halogen in the presence of non-polar solvent. ಈಗ ಈ ತರ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ what it will happen. Now here this pi bond it will readily this will be shifted towards this bromine, and here we will get the positive charge and this bromine will get the negative charge, and this pi bond it will readily abstract this which one, or else you will get it out. ಇದರಲ್ಲಿ symmetrical CH2 ಇದೆಯಲ್ವಾ. now this pi bond if it is shifted toward this carbon, now this carbon will get the which charge, negative charge. Okay, now this carbon will get the positive charge. Clear? Now this we are having the Br plus and we are having the Br minus alva. Now Br plus will be attacked here and the Br minus will be attacked here, and the product will get the CH ಇದರಲ್ಲಿ Br, ಇದರಲ್ಲಿ CH, ಇದರಲ್ಲಿ CH, ಇದರಲ್ಲಿ Br. Clear? Now this is the product we are getting for the addition of the halogen. Clear? Now ಈಗ CCl2 ಕೊಟ್ಟಿದ್ರಂದ್ರೆ now what the product will get, CH3 CHCl, now CH2 Cl. now this is the product we'll get. For this reaction. Clear? ಈಗ ನೆಕ್ಸ್ಟ್ addition of hydrogen halides. Now ಈಗ addition of hydrogen halides, this is a very very important. ಈಗ ತುಂಬಾ ಕ್ವಶನ್ಸ್ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಇಂದಾನೆ ಕೇಳ್ತಾ ಇರೋದು. Now they are asking the number of questions from this concept, but they will mix this concept in the middle of the reaction. Now ಈಗ addition of hydrogen halides, addition of hydrogen halides, ಇದರಲ್ಲಿ x is the halogens, chlorine, bromine and the iodine. Now ಈಗ hydrogens are valid. Now first symmetrical alkenes, this is a symmetrical alkenes alva. Now HBr, now ಅದರಲ್ಲಿ with this is hydrogen halide. Now this is a symmetrical alkene. Now either the pi bond may be shifted towards this carbon or this carbon. ಈಗ if this pi bond has been shifted to this carbon or 1, ಇದರಲ್ಲಿ 2. Okay, if the pi bond has been shifted to the 1 number carbon, now 1 number carbon will get the negative charge and the 2 number carbon will get the positive charge alva. Sorry, now 1 number carbon will get the negative charge and the 2 number carbon will get the positive charge. Here now HBr, now H ಮತ್ತೆ hydrogen, now H has been, now Br is a more electronegative, and the Br it is having the negative charge and the hydrogen it is having the positive charge. Clear? Now the hydrogen will go and attack toward this carbon and the bromine will go and attack toward this carbon, and the product will get CH2 Br CH3. Now this is the product. Clear? Now ಈಗ ಇದರಲ್ಲಿನೂ ಸೇಮ್, either we can shift toward this carbon or this carbon. ಈಗ this carbon ಗೆ ನಾನು ಶಿಫ್ಟ್ ಮಾಡಿದಂದ್ರೆ this will get the negative charge and this will get the positive charge. Now ಇದರಲ್ಲಿ this is H plus and this is a Br minus. Now ಈಗ Br minus will go and attack here and the H plus will go and attack here. Now the product will get CH3 CHBr, now CH2 CH3. Clear? Now this is the product we are getting for the symmetrical alkenes. ಈಗ symmetrical alkenes ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ this is the product. ಈಗ addition reaction with the unsymmetrical alkenes. ಈಗ unsymmetrical alkenes ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ this is very very important. ಈಗ unsymmetrical alkenes ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡೋಣ. Now ಈಗ pi bond 1 2 3, here we are having the 3 carbons alva. Now here pi bond I am shifting towards the 1 number carbon. ಈಗ when I shifted the 1 number carbon, now I am getting CH3 CH plus CH2 minus. Now this we will get. Clear? If I shifted now pi bond to the 2 number carbon, ಈಗ 2 number carbon ಗೆ ಶಿಫ್ಟ್ ಮಾಡಿದ್ನಂದ್ರೆ now this will get negative. Now this is CH2 positive. Clear? Now among the 1 and 2, which is a more major? Now here we have to see the carbocation ಮತ್ತೆ carbanion stability. ನೋಡೋಣ. ಈಗ carbocation ಮತ್ತೆ carbanion stability ಅಲ್ಲಿ now carbocation stability 3 degree 2 degree 1 degree ಅಲ್ವಾ. carbanion stability 1 degree 2 degree 3 degree ಅಲ್ವಾ. ನಾವು ಇದರಲ್ಲಿ ನೋಡಿ, now this is a primary carbanion 1 degree. Now this is a secondary carbocation. ನಾವು ಇದರಲ್ಲಿ ನೋಡಿ, this is a 1 degree carbocation. Now this is a secondary carbanion. ಅಂದ್ರೆ this is unstable. Now this is a stable alva. Now the reaction will be proceed with this 1 and the HBr alva, H plus and the Br minus, H plus and the Br minus. H plus will be attacked toward this carbon and the Br minus will be attacked toward this carbon, and here we will get the products like this. Here we have to see the stable carbocation. ಇದರಲ್ಲಿ ಏನು ನೋಡಬೇಕಂದ್ರೆ we have to see the stable carbocation if they have given the unsymmetrical alkene. ಈಗ unsymmetrical alkene ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ಏನು ನೋಡಬೇಕು? stable carbocation ನೋಡಬೇಕು. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ಈಗ stable carbocation ನೋಡಬೇಕು, then attack will be happen. And this type of the attack we call it as a Markovnikov addition. This we call it as a Markovnikov rule or Markovnikov addition. ಈಗ Markovnikov addition ಅಲ್ಲಿ what we are going to say, negative part of attacking reagent will attack to the carbon contain less number of hydrogens. ಇದರಲ್ಲಿ ನೋಡಿ, ಈಗ this carbon is having the less number of hydrogens alva. Now when the negative part of attacking reagent will attack to the carbon which contain less number of hydrogen. Idralli carbon it is having the less number of hydrogen, adralli adigoskaraನೆ hydrogen has been attacked. Idralli carbon it is having the more number of hydrogens, it will not attack. Now this rule we call it as a Markovnikov rule. Markovnikov rule. Clear? Now here, now what is the answer for this one? Now this is H plus and this is Br minus. Modalna first we have to make the stable carbocation. If we make the stable carbocation, idralli will get the positive, idralli will get the negative. Now Br will go and attack here and the positive will go and attack here and we will get the Br. Now this is the product. Clear? ಈಗ symmetrical alkene ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ, ಈಗ symmetrical alkene ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ, it will not, symmetrical alkenes will not follow the Markovnikov rule. It will not follow Markovnikov rule. Okay, it will not follow the Markovnikov rule. It will not follow the Markovnikov rule. Yakandre here if you shift it will become secondary. If you shift here it will also become secondary. Only the unsymmetrical alkene ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೇನೆ it will follow the Markovnikov rule. ಈಗ Markovnikov rules ಅಂದ್ರೆ ಏನು? Negative part of attacking reagent will be attacked to the carbon which contain less number of hydrogens. Clear? Next. Again, next anti-Markovnikov addition. This is very very important. Anti-Markovnikov addition or crash effect. Now ಈಗ ಈ anti-Markovnikov addition ಅಲ್ಲಿ now what we are going to see andre, now this anti-Markovnikov addition will be happen in the presence of peroxide. Now idralli this is a benzyl peroxide upon light and light upon heating. Now this will give the idralli anti-Markovnikov addition ಅಲ್ಲಿ Markovnikov rule ಅಂದ್ರೆ ಏನು? Negative part of attacking reagent should be attacked to the carbon which contain less number of hydrogens alva. But ಈಗ anti-Markovnikov rule will be different to it. Now how ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, this reaction will be proceeds via free radical mechanism, but reagent it should be the HBr only. HCl and the HI will not give this reaction. Clear? Now here if any unsymmetrical alkene with the HCl in the presence of peroxide ಈಗ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ reaction will not be happened. ಯಾಕಂದ್ರೆ this reaction will be happened with the free radical mechanism. This reaction will be happened with the free radical mechanism. ಈಗ free radical mechanism ಅಲ್ಲಿ now chain propagation step it should be the exothermic. ಈಗ chain propagation should be the exothermic. HCl ಮತ್ತೆ HI ಅಲ್ಲಿ first step is the endo, HCl ಅಲ್ಲಿ second step is the endo. ಅದಕ್ಕೋಸ್ಕರನೇ these two reagents are not suitable for the free radical mechanism. These two reagents will not be suitable for the free radical mechanism. But HBr first step ಮತ್ತೆ second step ಎರಡು steps ಅಲ್ಲಿ it is giving the exo. ಅದಕ್ಕೋಸ್ಕರನೇ HBr is favor for the anti-Markovnikov addition. HBr in the presence of peroxide ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ it will give the anti-Markovnikov addition. Now the mechanism it proceeds via free radical mechanism. ಈಗ ಅಂದ್ರು ನೋಡೋಣ. ನೋಡಿ, see HCl and the HI does not show the peroxide effect. Clear? Or Karash effect. Now free radical propagation step are exothermic. It should be exothermic. Free radical propagation should be the exothermic. But ಈಗ HCl ಮತ್ತೆ HI ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ first step for the HCl ಅಲ್ಲಿ first step is exo, second step is endo. So ಅದಕ್ಕೋಸ್ಕರನೇ it is not suitable. ಅಂದ್ರೆ we have to, ಇಲ್ಲಿ ನೋಡಿ, if it is a endo, the reaction will be reversible and the chain would be broken. The reaction again it will be reversed. ಅದಕ್ಕೋಸ್ಕರನೇ the HBr is suitable for the anti-Markovnikov addition. Only the anti-Markovnikov addition. ಯಾಕಂದ್ರೆ ಎರಡು ಸ್ಟೆಪ್ಸ್ ಅಲ್ಲಿ ಚೈನ್ ಪ್ರಾಪಗೇಷನ್ ಎರಡು ಸ್ಟೆಪ್ಸ್ ಅಲ್ಲಿ HBr is exothermic. ಅದಕ್ಕೋಸ್ಕರನೇ HBr is only the favorable for the anti-Markovnikov addition. HCl ಮತ್ತೆ HI ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ it will not be happen. ಈಗ HI ಅಲ್ಲಿ directly it will react with the peroxide and it will be converted to the I2. Clear? With the HI in the presence of peroxide, directly it will convert to I2. ಅದಕ್ಕೋಸ್ಕರನೇ it is not useful. Only the HBr is only the useful. Now we'll see the mechanism. ಈಗ mechanism ನೋಡೋಣ. Now mechanism, free radical mechanism ಅಲ್ಲಿ 3 steps will follow alwa. One is initiation, next is chain propagation, next is termination. Clear? Now initiation ಅಲ್ಲಿ first radical initiate ಮಾಡೋಣ. Now this is a benzyl peroxide. Now homoletical cleavage, ಇದರಲ್ಲಿ ಒಂದು electron, now radical it has been generated. Now ಈಗ ಈ radical it will be react with the reagent. Now ಇದರಲ್ಲಿ this is one electron. Now this radical and this hydrogen, this radical ಮತ್ತೆ ಈ hydrogen, it will form the alcohol, primary alcohol, and it will generate the Br radical. That radical it will propagate the reaction. Now chain propagation reaction. Now ಇದರಲ್ಲಿ we are having the reagent ಅಲ್ವಾ, reactant ಅಲ್ವಾ. Now this is a reactant. Now CH3, this is unsymmetrical alkene ಇದೆಯಲ್ವಾ. Now this will also it will be homoletical, it will cleave. Now here when this homoletically cleave, here also we are having the two types of the reaction. Now CH, now ಇದರಲ್ಲಿ one radical, now CH2 radical. Now ಇದರಲ್ಲಿ CH3 radical, now ಇದರಲ್ಲಿ CH2 radical. Here we have to see the stability of the radicals. Clear? Now if the radical is attacked to the 1 degree radical, if the radical is attached here, now two steps I am writing. When the radical is attacked, now 2 I am writing. Now if the radical is attacked here, clear? Now Br radical. Now two conditions we are having alwa. Now first it is attacked to the 1 number carbon, 2. Now this is a 3 number carbon. Next the radical is attacked to the 2 number carbon. When the radical is attacked to the 2 number carbon, when the radical is attacked to the this 2 number carbon, now here 1 number carbon is having the radical. Clear? ಇದರಲ್ಲಿ 1 ಮತ್ತೆ 2 ಅಲ್ಲಿ ಈ ಎರಡಲ್ಲಿ which is more stable free radical? Now free radical stability order. Free radical stability order is also 3 degree, 2 degree, 1 degree. Clear? 3 radical stability order also 3 degree, 2 degree, 1 degree alwa. Now ಈಗ after the homolytic cleavage we are having the 2 radicals alwa. One condition. ಈಗ if this radical is attacked to the 1 number carbon, we are getting the secondary radical. Now secondary radical. If it is attacked to the 2 number carbon, we are getting the primary radical. Among the 2 degree radical, among the primary radical, 2 degree radical is more major. 2 degree radical is more major, and this is a minor. So this is a minor, and this is a major. And now the reaction will be proceed with the major. Clear? Now here we are getting the 1 degree. When the bromine radical is attacked to the 2 degree secondary carbon, second number carbon, we are getting the 1 degree radical. When it is attacked to the 1 number carbon, we are getting the secondary radical. Secondary radical is major alwa. Now the reaction will be proceed with the secondary radical, and this is a major. Now chain termination step. Iga chain termination step alli this is a secondary radical. Now this is a secondary radical alwa. Sorry. Now this is a secondary radical. Now here again the HBr we are having. Again it will be broken. Now this H1 will be attacked to this radical, and again the Br radical has been generated alwa. Now this Br radical, again the chain propagation step, free radical mechanism andre again the Br will be formed. Again it will be attacked to the reagent. Again it will form Br and the Br2, and again the reaction keep on proceeds, and the product will get this major product, because chain termination alwa. We have to stop the reaction. Keep on proceeding. This HBr again this radical will form, again this radical, again it will be react with this reagent, again it will form the secondary radical, 2-degree radical, again it will keep on forming, and this it will give, and this it will give, and this it will give as a major product, and this it will give the major product. Adgoskarane it is giving the anti-Markovnikov of addition, anti-Markovnikov of addition. Clear? Now Markovnikov and the anti-Markovnikov of addition alli this is the difference. Clear? Now here ಈ ತರ ಕೊಟ್ಟಿದ್ದೀರಂದ್ರೆ HBr it will be, this is a Markovnikov of addition alwa, Br minus. Clear? Now here if it is shifted like this, now here the negative charge, here the positive charge. Clear? Now this positive charge can be stabilized by the methyl shift alwa. Now here the negative charge, and this is a positive charge, and here we are having that HBr. Now H will be attacked here and the Br will be attacked here, and the product will get Br, and here the H. Clear? Now this is the product. Now idralli we will get this product. Now idralli this is the product. Now this is Markovnikov of addition. This is a Markovnikov of addition because HBr with the absence of peroxide, Markovnikov of addition. HBr with the peroxide, anti-Markovnikov of addition alwa. Now next one. ಈ ತರ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ HBr with the peroxide. ಈಗ HBr with the peroxide anti-Markovnikov of addition alwa. This is anti-Markovnikov of addition. This is anti-Markovnikov of addition. HBr without peroxide. Now this is a HBr without peroxide. Now HBr without peroxide. HBr with peroxide. HBr with peroxide anti-Markovnikov of addition. HBr without peroxide Markovnikov of addition. Iga this you have to remember with the peroxide and the without peroxide. Iga with peroxide ಕೊಟ್ಟಿದ್ರಂದ್ರೆ with peroxide with ಕೊಟ್ಟಿದ್ರಂತೆ anti-Markovnikov of addition. Without peroxide ಕೊಟ್ಟಿದ್ರಂದ್ರೆ Markovnikov of addition. Clear? Addition of water. Now this is also very important. ಈಗ addition of water ಕೊಟ್ಟಿದ್ರಂದ್ರೆ now the pi bond should be shifted toward the 1 number carbon or 2 number carbon. Now ಈಗ 1 number ಈಗ pi bond if the 1 number carbon shift ಮಾಡಿದೆ ಅಂದ್ರೆ now here also we'll get the two types CH3 C positive, CH2 minus, ಇದರಲ್ಲಿ CH3. Clear? Now ಈಗ if it is shifted to toward the 2 number carbon, pi bond if it is shifted toward the 2 number carbon, now we will get this one minus CH3 CH2 positive. Clear? Now here ಈಗ ನೋಡಿದೀವಲ್ವಾ, now this is a stable, this is a major, ಯಾಕಂದ್ರೆ primary carbanion, secondary carbocation. Now here the H plus ಇದೆಯಲ್ವಾ, now this will be attacked towards this negative charge and we'll get the CH3. Now this is a minor, clear? Now this is C positive CH3, now this is CH3. Clear? Now H2O ಇದೆಯಲ್ವಾ, it will shift to the H plus and the OH minus. Now this OH minus will go and attack here and the product will get CH3 COH CH3, the CH3, 3-degree alcohol. We'll get the 3-degree alcohol. Clear? Now this is a minor, this is a major. ಅದಕ್ಕೋಸ್ಕರ the reaction proceed with this intermediate and we'll get the 3-degree alcohol. ಈಗ ಈ ತರ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ now the pi bond will be shifted toward this one. Now this will get the positive charge alwa. Now here this is having positive charge. Now this will be obstructed by this one. In the dehydration of alcohols, I said alwa, ring attached carbon, if it is having a positive charge, that is stabilized by the ring expansion alwa, Now 1 2 3 4 5 6, now it will be stabilized to the 6 number carbon. Now the 2 number carbon will, now if it is 1 number carbon, now it is having the CH3. Now 2 number carbon, it is having the positive charge. Now this carbocation is stabilized by the ಕಾರ್ಬೋಕ್ಯಾಟಯನ್ ಇಸ್ ಸ್ಟೆಬಿಲೈಸ್ಡ್ ಬೈ ದ ಸೆಟ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಅಲ್ವಾ. ನಾವು ಸೆಟ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಅಂದ್ರೆ ಏನು, ನಾವು ಸೆಟ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಅಂದ್ರೆ ಏನು, ಹೈಡ್ರೋಜನ್ ವಿಲ್ ಬಿ ಎಲಿಮಿನೇಟೆಡ್ ಫ್ರಮ್ ದ carbon which contain less number of hydrogen. So hydrogen will be eliminated from the here ಯಾಕಂದ್ರೆ here the hydrogen is having 2. Now the product will be in this manner. Clear? You have to be very careful. ಈಗ ಈ ತರ ಕ್ವಶನ್ ಕೇಳಿದಿರ ಅಂದ್ರೆ you have to be very careful. Now here cyclo group attached carbon having positive charge, that is stabilized by the ring expansion. Clear? Now don't think that the product will be in this manner. Clear? Now in the options they will give like this only. Options they will give in this option will be there. ಈಗ ಈ ಆಪ್ಷನ್ ಇರುತ್ತೆ, ಈ ಆಪ್ಷನ್ ಇರುತ್ತೆ. ಆಪ್ಷನ್ ಅಲ್ಲಿ ಈಗ ಈ ತರ ಕ್ವಶನ್ ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ ಈ ಆಪ್ಷನ್ ಇರುತ್ತೆ, ಬಟ್ ದಿಸ್ ಇಸ್ ನಾಟ್ ದ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ದಿಸ್ ಇಸ್ ಅ ಮೇಜರ್. When the hydride shift, when the carbocation is stabilized by the ring expansion, carbocation is stabilized by the ring expansion. When the hydride shift ಮತ್ತೆ ring expansion, ಈಗ hydride shift ಮತ್ತೆ ring expansion ಅಲ್ಲಿ ಕೇಳಿದ್ರು ಅಂದ್ರೆ ring expansion is only the more major. ಹಿಂಗೆ ಇನ್ನೊಂದು ಡೌಟ್ ನಿಮಗೆ ಬರುತ್ತೆ, ಸರ್ ಇದರಲ್ಲಿ one hydrogen ಇರುತ್ತಲ್ವಾ, why can't we shift the hydride? ಇದರಲ್ಲಿ CH2 CH3 ಇದರಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ನಾವು ಹಿಯರ್ why can't we attack the OH here? ನಾವು ಈಗ ಈ ಆಪ್ಷನ್ ಇರುತ್ತೆ, this option will also be present in the option, but when it comes to the hydride shift ಮತ್ತೆ ring expansion, this is hydride shift. This is ring expansion. Hydride shift ಮತ್ತೆ ring expansion ಅಲ್ಲಿ ring expansion is only more major and not the hydride shift. ಈಗ hydride shift ಮತ್ತೆ ring expansion ಈಗ ಎರಡು ಕಾಂಟ್ರಾಡಿಕ್ಟ್ ಆಗಿದೆ ಅಂದ್ರೆ ring expansion is only the more major than the hydride shift. Clear? ಈಗ ಈ ತರ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ now it will be shifted and here will get the positive charge. Now here CH plus and here it is the CH3. Now here the ring expansion will happen alwa. Now here this carbon is positive, negative. Now idralli CH3, now idralli negative. Now this will be, so this is positive. Clear? 1 2 3 4 5 6. Clear? Now 1 number carbon ಮತ್ತೆ 3 number carbon, 1 number carbon it is having CH3, 2 number carbon positive ಮತ್ತೆ CH3 carbon is also having the. Now this carbocation is stabilized by the set of product alwa. Now this carbocation is stabilized by the set of product. ಇದರಲ್ಲಿ 1 hydrogen, either we can remove from here, either we can remove from here. Now the product will get in this manner. Okay, now this is a product. Clear? ಈ ತರ ಕ್ವಶನ್ಸ್ ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ you have to be very careful. Clear? Oxidation. Now this is very important. Now oxidation of the alkenes. ಈಗ oxidation of the alkenes we can see it by the cold alkaline KMnO4, cold alkaline or dilute KMnO4 ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ that we call it as a Bayer's reagent. Bayer's reagent is used to test for the unsaturation. Now decolorization of the purple color of the KMnO4 will say that now here in the given compound there is a unsaturation. Clear? Now this is alkene alwa. Now alkene upon the cold alkaline KMnO4 or cold KMnO4 in the presence of H2O will get the syn ಅಂದ್ರೆ same side. ಈಗ ಎರಡು side, this is syn, or else we can write like this also. Both are at same side. Same syn diols will get. This is OH diols. Syn diols will get. Now ಈಗ ನೋಡಿ KMnO4 ಅಲ್ವಾ, KMnO4 ಅಲ್ವಾ. Now it will be dissociate to the MnO4 minus MnO4 minus. Now this is the structure of MnO4 minus. Now here this pi bond will be shifted here. Now this pi bond will be shifted here, and now we'll get like this. Now here the H2O idealva. Now H2 upon hydrolysis we'll get the syn diol. ಈಗ see ethene upon the dilute or cold KMnO4 at 273 Kelvin upon addition of the water we'll get the glycol. ಇದರಲ್ಲಿ we'll get the glycol or syn diols we'll get. Okay, clear? Now cold alkaline KMnO4 ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ vicinal diols will get. Vicinal diols alva. Now this is vicinal ಯಾಕಂದ್ರೆ now OH group is attached to the adjacent carbons. ಈಗ same number of ಈಗ same carbon ಗೆ attach ಆಗಿದೆ ಅಂದ್ರೆ that is geminal diols. Clear? Now cold alkaline KMnO4 upon the cold alkaline KMnO4 upon the alkene we are getting the what we are getting diols or vicinal diols. Clear? Now ಈಗ with the hot or concentrated KMnO4 ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ಒಂದೇ ಒಂದು ನೆನಪಿಟ್ಕೋಬೇಕು. ಈಗ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ KMnO4 ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ಒಂದೇ ಒಂದು ನೆನಪಿಟ್ಕೋಬೇಕು. ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಬ್ರೇಕ್ ದ ಡಬಲ್ ಬಾಂಡ್ ಅದರಲ್ಲಿ ಒಂದು ಆಕ್ಸಿಜನ್ ಆಡ್ ಮಾಡಿ. ನಾವು ಇದರಲ್ಲಿ this is CH3 ಅಲ್ವಾ, CH3 clear? Now ಈಗ break the double bond. Now what we are getting, we are getting this is a ketone. Next we are getting the aldehyde. Now KMnO4 is a strong oxidizing agent. ಈಗ KMnO4 is a strong oxidizing agent. ಈಗ ನಿಮ್ಗೆ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಯಾವುದು, ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಯಾವುದು ಅಂತ ನಿಮ್ಗೆ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಆಲ್ರೆಡಿ ಐ ವಾಸ್ ಡಿಡ್ ದ ರಿಡಾಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ವಿಡಿಯೋ ಮಾಡಿದ್ದೀನಿ ನಾನು. ಅದರಲ್ಲಿ ಯು ಕ್ಯಾನ್ ಸಿ, ಅದರಲ್ಲಿ ಐ ವಾಸ್ ಎಕ್ಸ್ಪ್ಲೇನ್ಡ್ ವೆರಿ ಕ್ಲಿಯರ್ಲಿ ಹೌ ಟು ಐಡೆಂಟಿಫೈ ದ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್, ಹೌ ಟು ಐಡೆಂಟಿಫೈ ದ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್, ಅಂಡ್ ವಿಚ್ ಒನ್ ವಿಲ್ ಆಕ್ಟ್ ಆಸ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಅಂಡ್ ದ reducing agent. I was explained very clearly. ಅದರಲ್ಲಿ you can go and see redox reaction ಲೆಕ್ಚರ್ ನಂಬರ್ 1 ಅಲ್ಲಿ ನಾನು ಕ್ಲಿಯರ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಿ which is a oxidizing agent, which is a reducing agent. Now KMnO4 is a strong oxidizing agent. Now this aldehyde will be converted into carboxylic acid. Now KMnO4 ಏನ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ aldehyde will be ಇದರಲ್ಲಿ ನೋಡಿ, this is aldehyde ಅಲ್ವಾ. Now by breaking it will give the aldehyde further oxidized to the carboxylic acid. Clear? Next ಈ ತರ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ now this it will give the break the double bond and it will give the ketone and it will give the formaldehyde. ಈಗ formaldehyde upon the KMnO4 further oxidized to the, ಈಗ formaldehyde it is unstable and it is further oxidized to the carbon dioxide and the H2O. Further oxidized to the carbon dioxide and the H2O. Clear? Now this is also ಈಗ ನೀವು ನೆನಪಿಟ್ಕೋಬೇಕು. Clear? Next ಓಝೋನಾಲಿಸಿಸ್. ನಾವು ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಈಗ ಓಝೋನಾಲಿಸಿಸ್ ಅಲ್ಲಿ ಏನಿಲ್ಲ ಒಂದೇ ಒಂದು ನಾನು ಶಾರ್ಟ್ ಕಟ್ ನಿಮ್ಗೆ ಕೊಡ್ತೀನಿ. ದಟ್ ಶಾರ್ಟ್ ಕಟ್ ಇಫ್ ಯು ಫಾಲೋ ಯು ಕ್ಯಾನ್ ಪ್ರಿಡಿಕ್ಟ್ ದ ಆನ್ಸರ್ ವೆರಿ ಫಾಸ್ಟ್ಲಿ. ಏನಂದ್ರೆ ವೇರ್ ಎವರ್ ಯು ಸಿ ದ ಡಬಲ್ ಬಾಂಡ್, ಫಸ್ಟ್ ದಿಸ್ ಈಸ್ ದ ಮೆಕ್ಯಾನಿಸಮ್, ಜನರಲ್ ಮೆಕ್ಯಾನಿಸಮ್. ದಿಸ್ ಈಸ್ ಅ ಓಝೋನ್. ನೋ ದಿಸ್ ಈಸ್ ಅ ozone. The ozone will be in this manner. Now ಇದರಲ್ಲಿ negative charge. Now this will be the positive charge. Clear? Now the ozone will be in this manner. Now by reacting with the ozone, first we'll get the ozonide upon breaking, and the zinc plus H2O. Now it will give the one, it is giving the aldehyde, and one it is giving the formaldehyde. One it is giving the formaldehyde alva. Clear? Now ಈಗ ಓಝೋನಾಲಿಸಿಸ್ ರಿಯಾಕ್ಷನ್ ಕೇಳಿದ್ರ ಅಂದ್ರೆ O3ZnH2O. ಈಗ ಇದು ಒಂದು ನೀವು ನೆನಪಿಟ್ಕೋಬೇಕು. ಇದರಲ್ಲಿ ಜಿಂಕ್ ಕೊಟ್ಟಿಲ್ಲ ಅಂದ್ರೆ ದಿಸ್ ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ವಿಲ್ ಬಿ ಕನ್ವರ್ಟೆಡ್ ಟು CO2 plus H2O. ಈಗ ಜಿಂಕ್ ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ ನಾವು ಏನ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ಸ್ಟಾಪ್ ದ ರಿಯಾಕ್ಷನ್ ಎಟ್ ದ ಆಲ್ಡಿಹೈಡ್ ಸ್ಟೇಜ್ ಓನ್ಲಿ. ಓಝೋನಾಲಿಸಿಸ್ ಅಲ್ಲಿ ಜಿಂಕ್ ನೋಡಬೇಕು. ಈಗ ಜಿಂಕ್ ಇಲ್ಲ ಅಂದ್ರೆ formaldehyde, this aldehyde will be converted into carboxylic acid. Now this formaldehyde will be converted into CO2 plus H2O. ಕ್ಲಿಯರ್. ಈಗ ಜಿಂಕ್ ಇದೆ ಅಂದ್ರೆ ಜಿಂಕ್ ಏನ್ ಮಾಡುತ್ತೆ, ಇಟ್ ವಿಲ್ ಸ್ಟಾಪ್ ದ ರಿಯಾಕ್ಷನ್ ಎಟ್ ದ ಆಲ್ಡಿಹೈಡ್ ಸ್ಟೇಜ್ ಓನ್ಲಿ. But most of the ozonolysis question, they are asking the IUPAC name. Idralli they may give the IUPAC name, and here they may give the products. Idralli they may give the products, or else they may ask the IUPAC name of the reactant, or else if they give the reactant and they may ask the IUPAC name of the products. Clear ಆಯ್ತಲ್ವಾ? ಈಗ this type of question ನಿಮ್ಗೆ this concept ಗೊತ್ತು, ಬಟ್ ಈಗ IUPAC ನೇಮ್ಸ್ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಯು ಕ್ಯಾನಾಟ್ ಪ್ರಿಡಿಕ್ಟ್ ದ ಆನ್ಸರ್. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ನೆಕ್ಸ್ಟ್ ನೋಡಿ, ಈಗ ಈ ತರ ಒಂದು ರಿಯಾಕ್ಟೆಂಟ್ ಮತ್ತೆ ಓಜೋನಾಲಿಸಿಸ್ ಅಂತ ಕೊಟ್ಟಿದೆ ಅಂದ್ರೆ ಏನ್ ಮಾಡಕ್ಕಿಲ್ಲ, ಜಸ್ಟ್ ಬ್ರೇಕ್ ದ ಡಬಲ್ ಬಾಂಡ್, put the one oxygen here, put the one oxygen here. Now what we are getting, CH3, C double bond CH3. Now this is one acetone and one is formaldehyde. Clear? Now ಈಗ ಬೆಂಜಿನ್ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ wherever you see the double bond, ozonolysis reaction O3 plus zinc plus H2O, ಈಗ ಇದು ಕೊಟ್ಟಿದ್ರಂದ್ರೆ now wherever you see the double bond, break the double bond oxygen, break the double bond, put the one oxygen ಇದ್ರ. Now break the double bond, put one oxygen, clear ಆಯ್ತಲ್ವಾ? now ಇಲ್ಲಿ ನೋಡಿ, now give the numbering. ಈಗ ನಿಮಗೆ ಕನ್ಫ್ಯೂಸ್ ಆಗಿದೆ ಅಂದ್ರೆ ಫಸ್ಟ್ you give the numbering 1 2 3 4 5 6. clear? now ಈಗ 1 ಮತ್ತೆ 6, clear, 1 ಮತ್ತೆ 6. now this is 1 number carbon, now this is 6 number carbon. clear? now 6 number carbon ಅಲ್ಲಿ half double bond, now 1 number carbon ಅಲ್ಲಿ double bond break ಆಗಿತ್ತಲ್ವಾ? now clear? now put the oxygen. next 2 number carbon, now ಇದರಲ್ಲಿ 2 number carbon, 1 oxygen. next 2 number, this is 2 number carbon, now this is 3 number carbon, this is 2 number carbon, 3 number carbon allino double bond break ಆಯ್ತಲ್ವಾ? clear? next 5 number carbon, now 5 number carbon, next 4 number carbon. clear? now ಅಂದ್ರೆ 3 moles of double bond. if you break the benzene, now this is the answer we are getting, and they may ask how many moles of the C double bond O will get. clear? now next ಈ ತರ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ ನಾವು break the double bond, 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 break the double bond. now see here CH3, C double bond O. now here the CH3, C double bond O, C double bond, oh sorry, ಈಗ ಈ ತರ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ CH3, C double bond O, now ಇದರಲ್ಲಿ C double bond O. now this is a one product. next CH3, C double bond O, now ಇದರಲ್ಲಿ next C double bond O, double bond O. next ಇದರಲ್ಲಿ double bond O, see, next double bond O. now these are the three products we are getting, with this reactor. okay? now ozonolysis, ಈಗ ozonolysis reaction ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ ಒಂದೇ ಒಂದು, just break the double bond wherever you see the double bond and put the oxygen. but ಈಗ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ಏನ್ ಕೇಳ್ತಾ ಇದ್ರು, ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ they are asking the IUPAC names. ಈಗ ಕಾನ್ಸೆಪ್ಟ್ ನಿಮ್ಗೆ ಗೊತ್ತು, ಬಟ್ ಈಗ IUPAC names ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ you cannot predict the answer. ಈಗ by this our very important topic, ಅದು ಯಾವುದು, alkene. ಲೆಕ್ಚರ್ ನಂಬರ್ 1 ಅಲ್ಲಿ alkene ನೋಡಿದೀವಲ್ವಾ? now this is a alkene. ಕ್ಲಿಯರ್? alkene ಪ್ರಿಪರೇಷನ್ ನೋಡಿದೀವಿ, ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ನೋಡಿದೀವಿ, ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ನೋಡಿದೀವಲ್ವಾ? now next lecture ಅಲ್ಲಿ we are going to see the alkynes, and another lecture we are going to see the aromatic hydrocarbons. okay, see you. and ಈಗ ನಿಮ್ಗೆ ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದೆ ಅಂದ್ರೆ ಕಾಮೆಂಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಈಗ ಕಾಮೆಂಟ್ ಮಾಡಿ, ನಾನು ಕ್ಲಿಯರ್ ಮಾಡ್ತೀನಿ. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ಲೆಟ್ಸ್ ಸಿ. ಓಕೆ, ಬಾಯ್.